Morning, everybody online. Can you hear me? Can you see the screen?
Yes, sir.
Okie dokie. So this was the paper that the Sunday group did yesterday, the January 2018 paper. I'm sure that would have exhausted all the questions on this paper at some point, or maybe the majority of them, while practicing on the various topics. But basically doing it as a paper now. I've decided on the date we're going to do our next assessment. I'm not going to tell you. I'm going to turn up one day and I'm going to give you an assessment to see how we're progressing, how well we are learning from our mistakes. That's what the assessment is about. All right. All right. So the target for this paper is 55. You know, next week is going to jump significantly. So therefore, you absolutely must redo any question that you get wrong, I got wrong on this paper. Those who did not do the paper, you need to go and do it. Right? You need to go and do the paper, even if you did not do the paper. Those who did not do the paper, I mean, I can't gauge you. You can't gauge yourself because you're gonna be doing it after me. So remember that we have another paper that is for tomorrow. So those of you who did not do this paper, did not do any of the papers, you need to do the paper for tomorrow. So at least you have one more bite at the cookie to see where you're at. Right? You have to see how we're progressing. You can't go into the exam blind. You absolutely must see how we are progressing from week to week. Basically 3 weeks left. 3 weeks left for the exam, 3 weekends. All right. A couple of persons who said that they will join online. I don't see them yet. Let's see. I'm gonna send this one here at the message. Just me a second. Just give me a second. I'm gonna send this spirit a message because she told me that he would join. It's one of them, and there's another one who said that he would join online. I haven't seen it. All right, I did that. All right, so let's go. All right, this calculator right now is in radians. RAD, something I have to make sure of, guys. Make sure your calculator is in degrees. So I'm going to change it change it to degrees from now. It's very important that you do that kind of check if you want to use a calculator, especially in the trigonometry question. Calculator must be in degrees. All right, let's go. So the first question on this paper is the usual, more of the same. Use a calculator, otherwise to calculate the exact value of this thing. So again, we're going to put that in the calculator. Make sure that it appears exactly as it is on paper. All right. So it's a mixed number first. 5.5. Then that's a division sign. Another mixed number. 3 2/3. Then a plus 1 4/5. Mixed number again. I'm just gonna do that double check. Make sure that what you have there is correct. That's 3 1/3. That's like 3 1/3. Look at it as a fraction. That's it. 3 3/10, not 1/3. 3 3/10, 3.33. All right, so you have to look at it. I was saying 3 1/3. All right, 3 3/10. So it's 3 3/10. You can write this one. I can write that one. All right, so 3 3/10, which is same as 11, same as 33/10, or that. Students got that answer? Got that answer? You in the class, I'm asking, you got that answer? Huh? So I couldn't get it, so. Huh? I get this answer. So no answer. He said somebody don't get it, you know. All right, next question. Write this, calculate that and give the answer as exact values. So again, we're gonna go, let's just put it in the calculator. So it's 165 times, that's 0.38, and then that is squared. And then an exact value, it is 23.826 as an exact value. All right, make sure it's the correct thing we wrote. Yes, it is. Next part wants us to write the answer in A2 to 2 decimal places. That is this number right in the 2 decimal places, the 23.826. They want to correct to 2 decimal places. Let's mark it out. So these are your 2 decimal places. It uses 6 to correct that 0.82. It becomes 0.83. You correct it to 2 decimal places. And so it is 23.83. That's the answer right there. Then to write it to 3 significant figures. Let's do it. So again, it's 23.826. We're correcting it to 3 significant figures. First significant figure, the first non-zero value from left to right. So these are your 3 significant figures up to here. All right, using this 2, that position to correct that 23.8. It will not change it because the 2 is less than 5. So that remains 23.8 with 3 significant figures. All right, that's 23.8, 3 significant figures. Then I want it to the nearest whole number. So again, we have 23.826. Whole number comes before the decimal point. So the whole number stops right here. All right, before the decimal point. So you're going to use this 8 to correct that 23, which will increase it by 1. Because 8 is a value more than 5. So this then becomes 24 to the nearest whole number. So those are your answers. A very nice and easy question. So we get a lot of marks for that. Start the ball rolling on the way to 55%. Next question here says, Mr. Adams invested $5,000 in a credit union and received 5,810. So right away, this $810 is the interest on this $5,000. That's just 810 more than 5,000, inclusive of simple interest, and this was after a 3-year period. After 3 years. So let's identify it. First thing I want us to do is calculate the interest. The interest, can just write it down literally. It's 810. If you want to show some calculation, it's 5,810. That's what he received minus what he put in, 5,000. And so the interest, which we're going to refer to as I, simple interest, becomes $810. Am I right? $810. Then this value is your principal. Let's mark them out. This value is your principal because for the simple interest formula, we need a principal. We have the interest which we worked out from this number, that it is 810. I keep writing 100. 810, and this is the time in years. So this is a T in the formula. What we don't have is the rate. What we don't have is the rate. This question is asking us for the annual rate. So we're going to start out with the formula for simple interest, which is that I is PRT divided by 100. One of the easy formulae that everybody knows. And in this case, we're trying to make the R the subject, or trying to find the rate. So the matter of transposing everything away from the R. I'm going to multiply the 100 first. I get 100I equals the PRT. Then to leave the R as a subject, I need to divide by the P and divide by the T. All right? And so the rate would then be equal to 100 times the interest divided by the principal and the time. All right? And so we're doing this calculation up here now to find the rate. And when you get the rate, it's going to be already in percent, because the percent is taken care of by the 100 being there in the formula. So then that rate that we want becomes 100 times the interest, which was $810, divided by the principal, which was $5,000, and also divided by the time on the year, which is 3 years. The time must be in years. If they gave it the time in months, you have to divide it by 12 to get it in years. So this calculation is going to give us the interest rate, and it's going to be in percent. It's already in percent. All right. So it's a fraction 100 times 810 divided by 5,000, and also dividing by 3. Put that 3 beside the 5,000. So it's 5.4% is the interest rate. 5.4. All right. You put a percentage on it. You have to put a percent on it. Next question says, the length of time it will take for Mr. Adams' investment to double at the same interest rate. If the investment doubles, it means that's when the interest becomes equal to the principal. The investment doubles. So you put in 5,000 and it has doubled to 10,000. So it means that the interest is now equal to 5,000. When investment doubles, is when they have gained the amount of interest that is equal to the principal. So this situation means that the interest is now equal to the principal. You can do it like that, you know. Or if you like, you can put the interest is now equal to 5,000. But the investment has doubled. Then if I say the interest doubled, I think that the investment, the amount that he's put in, it has doubled. They put in 5,000, it has now reached 10,000. So it means that the interest gain is equal to the principal amount. So this is when the interest and the principal become equal. And this time, they try to find the length of time. So this question is asking us for the time. This question is asking us for time. You have to know what the question is asking you for. It's asking you for how long it will take for the interest and the principal to be equal. You can work it with the numbers, 5,000, but you can also work it with these symbols. So if we go back to the formula, right? Let's do it in a different color, which is that I equals PRT divided by 100. And we'll try to find the time. Again, we're going to multiply up the 100 and divide on the PR. So the time is going to be 100 times the interest divided by the principal and the rate. But remember that the principal and the interest equal. So because these two values equal, we can literally just cancel them out. We can divide them. They're equal, you know, this and this equal. So we can divide them out. So your calculation is going to just simply work out to 100 over the rate. All right? That's what the time is going to be. 100 divided by the rate. So the time that you're trying to find becomes 100 divided by the rate of interest, which is 5.4. And when you do that calculation, you'll get the time. 100 divided by 5.4. 100 over 5.4. And that's 18.5 years. The length of time it take for it to double. I'm going to put 18.5. That's 18.5 years. I put 18.6 because it says it doubled. So I'm going to put more than the thing. I was really 19 because you're going past 18. So it's going to be 19 years. Because assuming that the pay it out. Let's write it like this. Let's write it like this. I'm going to write 18.5 years, which is approximately, it would extend to 19 years. So after 19 years, his investment would have doubled. 19 years. Put it. But I got that? Anybody got it? What did you put? You put it 18.5. I think they give it a mark, say you put 18.5, but you know, generally speaking, these things they usually are reported at the end of the year, not during the year, unless you're gonna go and cut the investment. But they didn't give us those conditions. So if you put the 19 and so on, 6, you will give it a mark. I think they give you the marks, you put 18.5. Additionally, you have to say years, guys. You have to say years. You cannot just put on 18.5. The question asks for the length of time. Time can be in seconds, can be in minutes, can be in months, can be in weeks, can be in fortnight. You have to say years. Because it asks for the length of time. So if you never put the years, chances are you lose a month. You have to put the word years. Length of time is in years in this case. That finishes number 1. All right, hope everybody got full marks on that one. Start the ball rolling. Let's continue. So this now is what we call a binary operation. It says, given that A star B means this. It means that the first value before the star starts the operation goes here, and the second value goes here, multiplied by B, multiplied by 4, and then square root. That's all that means. So if we're calculating 1 star 2, it means that the 1 is going here and the 2 is going there. So this simply works out to be the square root of where the A is, we put in 1, plus 4 times where the B is, we put in 2. That becomes the square root of 9. 4 2 is 1, 4 2 is 8, or plus 1 gives me 9. Square root of 9 is 3, so the answer is 3. All right, next question says, we are to determine whether the operation star is commutative. So commutative means that when you reverse the order, the result is the same. So since we already know that 1 star 2 is 3, a good way to kind of test if it is commutative is to find an example where it is not commutative. So since they gave us this, a good way to check it is to reverse this order and see the value that they get. It's going to be different. So I want to check it by doing 2 star 1. It's a good way to check it. Reverse what you have already. And 2 star 1 would work out to the square root. Now the A now is a 2. So you're going to put the 2 here. Plus 4 times, and the B now is 1. 4 times 1. This then becomes the square root of what is that? 6. Square root of 6 is not 3. See that? This is 2 star 1 now. Now 1 star 2 give you 3. But 2 star 1 give you root 6. I don't even have to work out the value. They're not the same. So I've confirmed, I can say, therefore, 1 star 2 is not equal to 2 star 1. Meaning that when I reverse the order of operation, the result is not the same. Therefore, the operation is not commutative. So you can say, therefore, operation star is not commutative. And that is it. Very good? All right, that is it. Let's continue. I want to solve this inequality. That's a linear, simple inequality. Remember, solving this will be the same steps as solving 3 minus 2x equals 5, except that for this one, if there comes a point you have to multiply or divide by a negative number, you have to remember to reverse that inequality sign. All right? So essentially what we're doing, we're transposing everything away from this x to make it the subject. That's what solve means. Make x a subject. All right? So first I'm going to move the 3 over here, subtract it. I'm going to be left with negative 2x greater than 2. I'm subtracting 3 from both sides. Let's write it. I'm subtracting 3 from both sides, minus 3 from both sides. So because I'm subtracting, I don't reverse the sign. I only reverse the sign when I multiply or divide with a negative number. All right? That's what we have. Then now I need to divide by this -2 to make x alone the subject. So next I'm going to divide by a -2. Because I'm dividing with a negative number, I have to remember to reverse that greater than sign that is there. So ready now. I divide this side by the -2, it becomes x. The sign is reversed, it becomes less than. I divide this by -2, it becomes -1. But understand that? X is less than -1. And so we can go and say that is the solution. Next part wants us to represent that solution on the number line. X less than -1. Now, some people are going to do this question and get x greater than -1 as the answer, which is wrong. It is wrong. It means that you did not reverse the sign when you should. All right? So now we want to represent this on a number line. So the critical value or the boundary value is -1. So you put a circle on the -1 right here. I'm going to leave that circle unshaded because there's no equal on the inequality. And then I want less than -1 means that I want to the left. Values down here are less than -1. So I have to put the arrow pointing to the left. Now, if this thing had an equal on it, then I would shade this circle on the -1. But it does not have an equal on it. It does not. And so we leave it unshaded. Then we'll just write the x less than -1. And basically that's your number line. But all right to that? Very good. Online, everybody okay? Still there? Students online?
Yes, sir. Yes, sir.
All right. All right, good. All right, all right. All right, next question. And it's part of this question. It says 2 adult tickets and 3 children tickets cost $43. Statement 2, 1 adult ticket and 2 tickets for and 1 ticket for a child, 1 and 1. 1 ticket for a child is $18.50. Let X represent the cost of an adult ticket. That is X right here. X dollars. All right? And let Y represent the cost of a child ticket. That's Y right here. So this is 2X plus 3Y right here. So that is now equal to this amount, $43. And then down here it is 1X, which is X plus 1 adult ticket, 1 child ticket, sorry, is Y. That now is equal to $18.50. We can put 18.5. So those are 2 equations. See? Write 2 equations to represent information in X and Y. That is it right there. Get it from the statement. Let's move it down. That's it. Simple as that. All right? I don't have to put the dollar sign on it. It's okay. Next question says solve the equation to determine the cost of an adult ticket. This is asking for X. Just that when you get it, when you get the value of X, you have to put it in dollars. You put the dollar sign on it. So what we're going to do is solve these 2 equations simultaneously. So let's do it now. So we have 2X plus 3Y equals 43. And we have X plus Y equals 18.5. I'm going to use the elimination method. So to use the elimination method, what we want to do is get either the X values here to have the same size, or get the Y values here to have the same size. Let's say we want to eliminate the Y. Since it's X we want to find, let's eliminate the Y. So I need this equation to have a 3X on it. So for this equation to have a 3X on it, a 3Y, sorry, not a 3X, a 3Y, because I'm trying to eliminate the Y. I need to multiply this equation by 3 and leave this one unchanged. I'm going to multiply the second equation by 3, leave the first one unchanged. So the first one remains 2X plus 3Y equals 43. The second equation, when I multiply it by 3, it becomes 3x. I multiply this by 3 becomes 3x. Plus multiply this by 3 becomes 3y. Then I need to multiply this by 3. Let's do it quick. 18.5 times 3. 18.5 times 3. That's 55.5. 55.5. Then now, because I have the x value is the same, the y value is the same there, to eliminate them, I need to subtract one equation from the next. I'm going to use the larger one here, even the x value larger, to subtract the first one. So I'm doing equation 2 minus equation 1, but I just can write the word subtract right here. So the examiner knows what I'm doing. But I'm going to do the second one minus the first one. So if you focus on this side, 3x minus 2x gives me x. 3y minus y, y gone. Minus 3y, 3y minus 3y, y gone. Then that becomes equal to, on this side, I subtract the same value again. 55.5 minus 43. So here I'm just going to subtract 43 now. So I get 12.5. 12.5. So x is 12.5. So the cost of an adult ticket, therefore, is $12.50. And that is the answer, $12.50. So when I subtract, this is what I get. All right. So my answer is $12.50. Let's write that. So my answer is $12.50. 12.5. Next is 12.5. The money, which is the cost, must be expressed as money. It's $12.50. The $12.50 for one adult ticket, the X. All right, that finishes that question number 2. But I go to that. All right, number 3 now. All right, so number 3 starts out with a set. All right. You're not going to see sets on your paper 2, but you see it on the paper 1 for sure. A lot. You have to know sets. That's why I have to keep practicing. You have about 7 to 8 sets questions. Maybe up to 10 sets questions on that paper 1 exam. All right. Question says, the universal set B, D, E, F, G, I, K, S, T, V, whatever. All of these. All right? That's the universal set. And they're all in the Venn diagram here, in the various subsets. It says the Venn diagram below shows U and 3 subsets, M, P, and R, which are subsets of U. It says state this thing. Now, this N in front here means the number of elements. You're not stating the elements, you're stating the number of elements in the union of P and R. Now, the union of P and R are these. Let me circle them for you. This is P and R. So you have to do is list all the elements in P and R, but don't repeat any of them. No, you're counting. Sorry, you're counting. We're not going to list them. We just want the number of elements in there. We can literally just count how many values are there. This N in front, the set there means the number of values. So let's count them. It's 1, 2, 3, 4, 5, 6, 7, 8. 8 values in that union. P and R together, 8. So this answer right here is 8. 8 is the answer. They don't want it to list the values, guys. They want the number of values. That's what the N in front here means. Number of values in the set. The union of P and R. So P and R combined. There are 8 values in there. All right. Next question says, list the members of this now. M intersect P. So M intersect P, you can actually see it on the Venn diagram. So this is M, and this is P, and inside here is the intersection. I'm going to shade out in blue now. This is the intersection in here between M and P. So those are the letters B and D. So this is just equal to the set B and D. What go to that? P and D. All right, that's in the intersection of M and P, B and D. All right, this next one. This one can be a little bit tricky because of this union. It's a union of M and R complement. Remember, R complement means outside of R. So what can do for this one? I can literally maybe just list M and list R complement and then see what the union is. Remember, you don't repeat values. So M would be the set. Let's just set it up this way. So M would be the values in M right here. Values in M are K, B, D, I. K, B, D, I. K, B, D, I. Let's write those down first. K, B, D, I. Those are the elements in M. And then now I'm going to list the elements in R complement. So R complement is everything outside of R. Everything outside of R. So I'm talking about these around here. Those are all outside of R. That's what R complement means. Everything outside of R. So those values, let's write them down here, would be W, K, B, V, and S. S and also T. Well, let's identify the common ones so that we don't repeat them. So this answer now we know is equal to this answer. Let me write it out. M union R complement is a combination, everything together in those two sets. So M union R complement. Let's mark the common values first so don't repeat them. So you have B and B, or you also have K and K, don't repeat those. And then that's it. So don't make sure you don't repeat the ones that are underlined, right? Don't repeat the ones that are underlined. So we'll write them out from this set. We're going to ignore them over here. Okay? You cannot repeat any value. So that union, therefore, becomes KB. If the question asks for the intersection, if it was this, then this should be the answer, the K and the B. But it is a union that they want. So put in the K and the B. Then I'm going to put in the D and the I here now. And I make sure that I don't repeat these two. So I'm going to put in the W now. Then the V, then the S, then the T. And that is it. We do it step by step. Union is what is in M together with what is in the R complement. Union there, but don't repeat any of the values. Hey, touch a youngster there for me. You tired out from yesterday hour? Huh? Wake up, man. That's what happens when you don't do the mock exam. Wake up, Mr. Man. Sleep outside outside, you know. All right. Next question. This one wants us to do a construction, right? Let's sketch it before construct it. It says use a ruler, a pencil, and a pair of compasses. Construct triangle PQR, which PQ is 8. Let's sketch it out. PQ is 8. So I'm going to put P here, Q here. This is 8 centimeters. It says angle at Q, PRQ is 120 degrees. So angle at Q is 120 degrees. So you go around. So remember, it's 260, that's one. A 60 and another 60. 260 degrees make a 120, right? And then R is up here somewhere. And then QR is 5. So it's going to be 5 centimeters. And then the triangle is going to go like that. That's what you sketch. That's what you construct. This angle is 120 degrees. To construct 120, we'll construct 260, 60 and 60. We get the 120. Let's go. We're going to construct it now. Nice and easy. All right. Where is that thing? It's supposed to be on here. There you go. All right, let's construct this thing, right? We're going to draw the line PQ first, 8 centimeters. So bring in the ruler. I'm going to draw the 8 centimeters line. So let's measure 0 to 8. 8 centimeters. Then we want to construct a 120-degree from the right side. So bring in a compass now, bam. And we're going to put it here. Flip it around. They have to lock it, right? So remember, for 120, you need 2 arcs. You cross the first arc, you cross the second arc, you get the 120. You need 1 long arc to cover 120 all the way around here. You know that you have to go all the way around here. So you draw a long arc around there. All right. Then now, without changing the angle on the compass, or don't adjust the compass, you move the point to where the first arc intersect the line. And then you rotate around across that first arc. You make that cross right there. That's 60 degrees. When you move the point to here and cross again, that's a second 60 degrees. So you now have 120. So then all I need to do now is draw that line, straight line through that intersection. All right. So because I know I want a 5 centimeters, because I know I want a 5 centimeter line, what I can do is measure this thing 5 centimeters with my ruler. You can draw it to the ruler through there now and measure it 5 centimeters now, but I can also do it like this. Put the point on 0, open this to 5, lock it, let's change the color. And from here, I'm going to make an arc that is 5 centimeters. I know that my line is supposed to pass somewhere around here, so let's make an arc. So my line through the intersection out to that mark will be 5 centimeters out to there. All right. So then I can just draw my line now. Through this intersection out to that. It's the wrong thing. Sorry. I'm undo is gonna come off. So I must do it this way. Draw through the intersection out to here. That is 5 centimeters through the intersection. And that blue line is 5 centimeters from Q. So mark it there. Through the intersection is 120 degrees and it's also 5 centimeters out to that line. If you want, you can go past it like that and then still mark that spot as 5 centimeters, but you can come to it 5 centimeters. That's it. You want to complete the triangle now. From this other end, from P out to here, that's my triangle. Bam. I can write on it. This is P, this is Q, right up here is R. And the angle side is 120 degrees. This is 8 centimeters, and this is 5 centimeters. That's it. I think I want us to do something else on this question. So I want us to measure and state the length of PR. And then it says on your diagram, construct the point S such that PQRS is a parallelogram. So PQR, let's put it down here. So PQRS, you have to keep the consistency in the orientation of the letters. PQRS. So it's going to be a parallelogram. It means that S has to be somewhere up here on the sketch, such that this becomes a parallelogram now. So I'm going to mark out in red. PQRS. So therefore, to get that parallelogram, what I'm going to do is transfer this length up here. I'm going to transfer this length to over there. Okay, let's do the construction and then measure. So let's finish the parallelogram. So bring back the compass. This is already 5, you know. Look, remember it's already 5. This is already 5 right here. Let's change the color back to blue. All right, let's do that second construction in green. That's already 5. So I'm going to move that distance of 5. This is already 5. This is already 5. So I'm taking this distance of 5, open my compass to 5, and transfer that length over to this end. And make an arc. So that arc is 5 from P. Then now I'm going to measure by the 8. Put my compass to 8. Lock it. I need to transfer this length of 8 up here. But to do that, what I'm going to do is put the point over here at the R and push that the R and rotate the compass around. That's going to be 8. We'll do it again. So like I transfer this distance of 8. And I'm transferring it up here. So let's mark my arc. That is 8. So that point is 5 from P, but 8 from R. So when I move this now, I can complete the parallelogram. So let's draw a straight line from P up to that intersection. And then draw from the intersection over to R. And that's a parallelogram. This point is S. Right here is S. But they wanted us to measure what length? PR. So let's measure it. So the ruler here. You can actually use the ruler and rotate it up and measure it. Like that. Looking like about 11.3. What did it? What did you get? What you all got? That looks like 11.3. 11.3. Yeah, 11.3 I'm getting. Anybody did it? What you all got? 11.5? They'll accept it. That's all right. I'm getting 11.3. I'm going to put my 11.3 that I got. That's what I'm going to do. Put in my 11.3. So I'm going to put 11.3 right here. But if you get anywhere close to that, they give it a marks. 11.2, 11.3, 11.4, 11.5. Anything close to that, they give it another 1 mark. Leave. That is it. All right, next question. Question 4. Question 4 says, because of a straight line is this. First thing I want to do is write it in this form. Make y the subject. But when y is the subject, that's the gradient, and C is the y-axis intercept. So basically taking this equation, we're transposing everything away from the y. We're leaving y as a subject. All right? Yeah, but done quickly now. Can take the negative 4y, bring it over here, and make a positive 4 and then divide through by 4. But no matter. You can also do the other way, where transpose everything away from it. So let's write it out and show. So we have 3x minus 4y equals 5. I'm going to move this 3x first over to this side and subtract it. I'm left with minus 4y. No, don't throw away the minus. Becomes minus 3x plus this 5. You need to divide through by that negative 4. Or I can multiply through by a negative 1/4. Same thing. So if I divide everything by negative 4, this, and this. Divide each term by negative 4. Right? Then this side becomes just y. This negative 3 over negative 4 becomes a positive 3 over 4 times x. And this turns out to be negative 5 over 4. That is it. That is what it is. Now, another way to do it, let me just do it beside it, another way. let's do beside it, is to take this minus 4y and bring it over this side, and take this 5 and bring it over this side. So we would get, if we transpose it, let me write it back again. 3x minus 4y equals 5. Take this over here, it becomes a positive 4y. Take the 5 away, it becomes a negative 5. So leave the 3x on that side. You're going to get 3x minus 5 equals 4y. Then you're going to divide by the 4 now. Divide this by 4, divide this by 4, and divide this by 4. All right, so we divide everything by 4. You're going to be left with y equals 3 over 4x minus 5 over 4. And it's about spinning it around. So you actually get back, make this a little smaller. Actually get back what we had in the first case. So you actually get back y equals 3 over 4x minus 5 over 4. Same answer. Then I want us to tell them the gradient of the line. The gradient is the m right there. So we're going to write m equals 3 over 4. That's it. The number in front of x is the gradient. And I'm saying m because I'm referencing this m that they gave me in that equation. So the gradient is m equals 3 over 4. Next part says the point R2 lies on the line. Determine the value of R. R2 lies on the line. It means that this point R2 can be substituted into the equation of the line. Because it's a point on the line. All right? Why am I using that one? Because I'm trying to find an x value, not a y value. If I was trying to find a y value, I would use this one. So I'm going to use the top one. I have to do the mathematics the easy way. So because the point is on the line, it satisfies the equation of the line. So I'm going to substitute it in there. All right? So let's write it this way. R2 satisfies the 3x. What did they give us? 3x minus 4y equals 5 because it's a point on the line. So you can substitute this for the x here and substitute the 2 for the y there. So when you do that, you can say therefore 3r because the x is r minus 4 times 2 because the y is 2 is equal to 5. Then this becomes a negative 8. They go a small space to give you, they don't expect a lot of work in it. It's small space that they give you. This becomes negative 8. Work with me now. Negative 8 going to go on this side to become a positive 8. 5 and 8 is 13. So you're actually going to get 3r equals 13. Let me shift it to the left. All right? And then if 3r equals 30, we better consider that this is a negative 8. Negative 8 comes on this side, become a positive 8. 5 plus the 8 is 13. That's why I get the 13 right here. Then I'm going to divide by this 3 to make r the subject. So I'm going to get now that the r equals 13 over 3. 13 over 3. Anybody got that? Nobody here got that? Nobody got that? You got it? All right, good. Next question says, find the equation of a straight line passing through this point, which we're going to call P for reference, passing through that point, which we're going to call P, and is perpendicular to L. We're going to call that line line 2. Since this is perpendicular to L, the gradient of this second line is minus 1 over the gradient of the first line, which we call the gradient of the first line M from up here. So, because they are perpendicular, they have negative reciprocal gradient. So we want the perpendicular gradient to 3/4. You get that quickly by flipping the 3/4 and changing the sign. So instead of waste time working out this calculation, we can just flip this gradient and change the sign, and that will be the perpendicular gradient. That will become -4/3. If I take this 3/4 and flip it, change the sign, it become -4/3. So then I'm using this gradient and this point. Let me write out the values, 60. I want the equation passing through this point that has this gradient. So we can use the BFF formula. Let's do it in a different color. So we're going to use y minus yp, because we'll call the point up here p that it passed through, equals the perpendicular gradient, which is called M2. This perpendicular gradient, we'll call it M2, into x minus xp, because we'll call the point p right there. That will give us the equation of the line. We have to know that formula. Think on a formula sheet, might be y minus y1 equal m into x minus x1, something like that. And some teachers teach it that way. So dropping in the values now. So it's y minus yp is 0. The perpendicular gradient is this. Perpendicular gradient is that, -4/3 into x minus xp. The x value at this point is 6. So this just remains y, because y minus 0 is just y. We're expanding this bracket now. So -4/3 times x. Then this minus is going to give me a plus value. I know that. The 3 into the 6 going to go 2 times, and the 2 times 4 is 8. So I'm going to get a plus 8 right here. That is the answer. -4/3x plus 8. Y equals -4/3x plus 8. This question we're not supposed to miss. We're supposed to lose marks on this question, because the same thing all the time they're asking. To find the equation of a line, you need to know the gradient and the point. So you can put them in the BFF formula. All right. Some people use y equals mx plus c and use the point to find the c. No problem if you want to do it that way. No problem. Do it that way and get the same answer. I'm good. All right. Let's continue. This one wants us to draw the line x plus y equals 10 and line y equals x. One of the easiest lines ever to draw. That's an x plus y line. Equals 10. So it crosses the y-axis at 10 and also crosses the x-axis at 10. That's this first one. Passes through points where the sum of x and y is 10. So therefore it also passes through 5, 5. So you need a line passing through those points. Right? So to be a straight line like this, I can't draw a straight. I was trying to see if I could get the app to draw a straight line, but they only allow this app to do it when it uses the S Pen, which this tablet does not use the S Pen. So that is it. That's it. X plus y equals 10. Then you want the line y equals x. Y equals x is the other easy line to draw, passing through points where the x and y values are the same. And so it passes through this origin 0, 0, and it will also pass through this point 5, 5. So that line will go up the middle of the graph because the scale and the x and the y axis is the same. And so it will go right up the middle of the graph like this. Use your ruler to do it. I cannot get it to a straight line with this app, so just work with it. So basically, this is it line. And don't stop it there. Extend it all the way through. And label it up. This is the line. Y equals x. Draw it with your ruler. All right. Y equals x. All right. So draw the lines in the first part. The next part now, so we shade the region that satisfies following 4 inequalities. Let's do them one at a time. So this one first. X greater than 0. This means above, just for the purpose of the class. Greater than means above. So this means above x equals 0 as a solid line. X equals 0 is actually the y-axis. Above the line, x equals 0. Let's write it. Above the solid line, x equals 0. The equation of the line associated with this inequality is x equals 0. So x equals 0, remember now, is the y-axis. And so you really want to go above this vertical line. So you put the arrow pointing to the right. I want to the right of this line. So the region that I want is somewhere over here, to the right of that line. So far, right? The next one is now y greater than 0. This one now means above solid line again. Why is it solid? Because the equals are part of the inequality. And the line we're talking about is the one associated with this inequality, y greater than or equal to 0. That line is y equals 0. But y equals 0 is your x-axis. So the region that you want, therefore, is above the x-axis. Put it in red. So the region that you want is somewhere over this quadrant so far. All right? Let's continue. The next thing is this one. Now, when the equation is like this with the x and the y in it, like those two things, you want the y to be on the left side of the inequality. Right? And they also want it to be positive. That is the case here. The y is on the left side, it is positive, and therefore this less than means below the line. In terms of which part of the line I want. So this therefore means below, or the y over here is positive, less than means below. The line is solid because the equals are part of the inequality. Now, I already said you have to write out on the exam, and I'm just telling you the chain of thought, what you should be thinking. Right? So this line is solid, which you do have, and the line is the one associated with this inequality, which is the x plus y equals 10 line. And so you want below that line. So I'm going to put the arrow now. See x plus y equals 10 line here, this one. This one down here. This one. We want a region below that line. So I'm going to put the arrow pointing down. So the region I want so far is here. So far, those three inequalities will be pointing to there. To the right of the y-axis, above the x-axis, and below the line x plus y equals 10. So the final answer is going to either be inside here or inside here, depending on how we interpret this inequality. So right now, this inequality is not set out in the friendly manner for us, the way we learn it. Remember, once it has an inequality includes the x and the y, and it is linear, you want the y to be on the left side, and you want it to be positive. That's a young said that for me. Now I learn nothing. Don't you know what that's for me? Can't sleep and learn nothing about it. So therefore, I'm going to turn this around. Because if you go and read the greater than sign, you might want to think it means above. But greater than means above only when the y is on the left side. Right now, the y is on the right side. So this greater than right now really means below. You get me? It really means below. So if I turn it around, that inequality, and write it instead as y less than or equal to x, read it the other way. Read it from left to right, from right to left, sorry. To say x is greater than or equal to y, it's the same as saying y is less than or equal to x. I'm reading it this way so that the y is on the left side, it is positive. So therefore, no, this less than means below. And that's where a lot of people get this question wrong. They put it to the greater than sign and go above the line. So that means below, solid line again. But the equal is there, and the part of inequality is a solid line. And the line associated with this inequality is a line y equals x, which we have. So I'll go below that line as well. So We also want the region that is below this line. So if we're going below both lines, this is the region that we want here. That's the region that we're supposed to shade. Let me mark it. Because that region now is below this line, it's below this one, it's above this one. And so this is the region that we want inside here. So that's the region you're supposed to shade. People who read this inequality as above would have shaded in here, which is wrong. All right, that's the region you're supposed to shade right there, guys. All right, put my time on this one because I want you to understand it. If you don't. All right, let's continue. But I don't set these very often, so let's go. This question now, Zachary asked me about this question yesterday. And we jump to the second part, but we need the information from the first part for the second part. Can't do the second part by itself without doing the first part. But let's go. This question says, the regular polygon, regular means all sides equal, all angles equal. So regular polygon, EFGHIJ, shown below, the center is O. It says, OEF is an equilateral, triangle OEF is equilateral, that's this one. And they tell us that this is 5. So if it is equilateral, then we say this is also 5, and this is also 5. And if equilateral means that all angles inside are 60 degrees. So it's 60 degrees, 60 degrees, 60 degrees. So some of the students actually did the SBA with this thing the other day. Same shape. And same shape. So basically, what does that mean? Equilateral triangle, right? Everything equal. Let's answer the question. It says, what is the name of the polygon? It has 6 sides. So it's a hexagon. Six-sided polygon is a hexagon. Simple as that. Next part. Calculate the perimeter. Perimeter, the want to know. The perimeter, since it's regular, all the sides equal. It has 6 sides. So the perimeter is 6 times 5 centimeters. 6 sides, 5 centimeters. That's the perimeter the want, the distance around it. That is 30 centimeters is the distance around that polygon. But okay with that? Nice and easy. All right. Next part wants us to determine the size of the interior angles of the polygon. So when they say the one interior angle of the polygon, they're talking about these angles, these between the sides. They want to know what the interior angles are. We can do this multiple ways. We already decided that this angle right here is 60 degrees. But regular, so if we form another triangle here, then this angle also is 60 degrees. And so the total angle across here will be 120 degrees. So each interior angle is 120 degrees. That's one way to do it. Another way to do it is to use what the total angle inside there would be and divide it by 6. Remember that. Remember a polygon, the total interior angle will be equal to n minus 2 triangles. And each triangle is 180 degrees. And that will be 6 minus 2 times 180 degrees. That will be the total interior angle, which will work out of what? 720. 720, right? That's it. And then each of them equal because it's regular. So therefore, each angle will be 720 divided by 6 because there are 6 angles in there. So each of them will be 120 degrees. That's another way to work it out. Right? But let me show you another nice way to work it out. Let me show you another nice way to work it out. Just for us to remember. So I show you the 2 ways so far, right? I'll show you another way that you could use to work it out. Now, remember that a polygon total exterior angle of a polygon is 360 degrees, regardless of the number of sides. So because it's regular, all exterior angles equal. So the total exterior angle is 360 degrees enough. So see here now, total exterior is 360 degrees. It's regular, so each exterior angle you divide by 6 is 60 degrees. Now, 180 degrees minus the exterior angle equal an interior angle. An exterior angle and an exterior angle add up to 180 degrees. Look. So we take this side, for example, right here. Extend it. This is exterior angle now, right here. This is 60 degrees. This is a straight line. So inside here must be 180 minus 60, which is 120 degrees. That's another way we could do it. So since each interior angle is 60, it means that since each exterior angle is 60, it means that each interior angle becomes 180 degrees minus 60 degrees, which is 120 degrees. So 3 different ways of putting it. Which is the fact that the total exterior angle of any polygon is 360. Since this has 6 sides, each exterior angle is 60 degrees. 360 divided by 6. Let me write it. Let me shut up here. I'm going to actually leave this as a solution. I'm going to leave this one. I'm giving you 3 different ways. So I'm going to say each exterior angle is 360 degrees divided by 6 because there are 6 sides. So it has 6 of everything. 6 sides, 6 angles, 6 vertices, 6 interior angles, 6 exterior angles. Because it's regular, all of them equal. So 360 degrees is the total exterior angle. Divided by 6, each of them is 60 degrees. And if an exterior angle is 60 degrees, then the interior angle is 180 minus 60. And that's how we get the 120. So I give you 3 ways. I'm going to leave this one as the solution on the paper. This one. Give you 3 ways. So let's copy this down and put it down here. Right here. I'm going to leave this one as the answer. I think that's a neat way to do it. All right, that is that. Not that. All right, so over here, we use the total angle. Find the total angle in there first, because it's 6 sides, and then divide by 6 to get each one. And here is a geometry method. We looked and say, okay, if this is 60, then this must also be 60. So total across here is 2 times 60. And then we use the total exterior angle approach. All right. Next question. Says, show by calculation that the area of the polygon is to the nearest whole number is this. So remember now, there are 6 of these triangles in there. So if you can find the area of one of those triangles, multiply that by 6. Now, what's the area of a triangle now? This triangle. We're not going to bother with the base and the height. Because we have the 3 sides. This is 5 centimeters. This is 5 centimeters. And inside this is 60 degrees because it is equilateral. We're going to use the area of a triangle that says area of a triangle is half AB sine C when you know 2 sides and the angle between them, which we do in this case. Just that in this case, the A and the B, each of them is 5 and the angle between them is 60 degrees. So this calculation will give us for the area of one of the triangles half 5 times 5 times the sine of 60 degrees. That's what we're going to use the area of one of them triangles. And the 6 of them we need for the hexagon. So let's copy this down. Okay, I'll leave it. Let's copy this down. Just going to use this one. Let's copy this down. Paste it down here. All right. I'm going to say the area of the hexagon equals 6 times the area of one of the triangles. So area of one of the triangles is this. So it's going to be 6 times half A B sine C. That's going to give it the answer. I'll show you work it out. You're going to get the 65 centimeters squared to the nearest whole number. Let's do it. Six triangles in there. Each of the triangles carry the same area. It's regular, everything equal. So it's 6 times, well, I can say this 6 times a half is 3, right? So it becomes 3 times 5 times 5 times the sine of 60 degrees. There you go, 64.95, which is approximately 65. So that is good. All right, nice and easy. All right, that is that. Down here now. Next part says, a tank has a cross section with dimensions identical to the polygon of the top. So we know that the cross-sectional area A is equal to 65 centimeters squared. But that's an object with uniform cross-section. So the formula that governs object with uniform cross-section is that the volume is equal to the cross-sectional area times the length. In this case, the length will be the height. All right? The length will be the height in this case. So we're going to put, instead of L, I'm just going to put H. All right? For height. That's one of the formula that governs this topic. All right, remember also curved surface area and total surface area. But anyway, they say water is poured into the tank at a rate of 75 centimeters cubed per second. This is not complicated, guys. After 55 seconds, the tank is 2/5 full. 2/5 full. All right. So the question is, determine the capacity of the tank in liters. What is now? 2/5 full is the amount that is in there after 52 seconds filling at this rate. Remember now, every second, then put 75 in there. That's what that means, you know. 75 cm cube per second means that every second, 75 cm cube goes into the tank. Therefore, after 52 seconds, the amount going into the tank is going to be 52 times 75. So you can write it up, set up like this. And I say it is 2/5 full. So see here now, I'm going to say 2/5 full. 2/5 full volume is equal to 52 seconds pumping at 75 cm cube per second. Whatever this is 2/5 full. And I'm trying to find the full volume because capacity is full volume. Simple as that. So to get the full volume to be the subject, I can multiply the 5 and divide under the 2. So it means then that the full volume, which is the capacity, becomes 2 times 52 times 75 divided by, no, times 5, multiply by 5. So it's 5 I need here, not 2. I need a 5 right there. Multiply by the 5 and take this 2 and divide it under here. And that becomes your full volume, which is the capacity. So the full volume then becomes equal, but I want it in liters, and it's going to give us in cm cube, you know. It's going to give us in cm cube. Remember now that 1 ton cm cube make a liter. So if I get the cm cube and divide by a ton to get liters, let's see what this is. What happened there? Press the wrong button, you know. Move it back. Press the wrong button. I close the file I'm working on accidentally. I closed it. All right, let's get it back. Press the wrong button. All right, back here. All right, good. So I'm going to do this calculation to get what the full volume is, which is the capacity. Capacity is full volume. So it's going to be a fraction 5 times 52 times 75. I'm putting that over 2. I'm getting 9,000 9750 cm cube. 9750 cm cube. But I want liters, I divide by 1,000. That is equal to 9.75. 9.75 liters. I'll get the 9.75 divided by 1,000. Move the decimal point 3 places to the left. Divide by 1,000. 1,000 cm cube. Like a liter. So that is the volume when it is full. That's a full volume. That is the capacity. Capacity is full volume. So that is the capacity. All right. So remember now, this calculation is the amount when it is 250, but I don't have to work on the actual value of it. I don't need it. Get me? And I just was calculating the full volume. All right. Next part now says we have to calculate the height of the tank. So remember now that the full volume is the cross-sectional area times the height of the tank. Our the cross-sectional area is 65. So to get the height of the tank, we divide by the area. So the height of the tank is the volume over the height, over the cross-sectional area, sorry. Therefore, the height becomes the volume. I have put back in cm cube, but they want to say meters now. So I want to get it in centimeters first, and then we're going to convert it to meters. So the volume in cm cube is this when it is full. 9750 divided by the area was 65 centimeters squared. The area of the cross section, 65 centimeters squared, cross section area is 65. Word I thought we're gonna get it in centimeter, but I want the answer in meters. So it means that we have to divide this 9750 by 65. I'm getting 150 centimeters, but I want it in meters. So remember, it is 100 meters, 100 centimeters, sorry. That makes a meter. So we have to divide it by 100. So it's 1.5 meters. You divide by 100. Remember, 100 centimeter equals 1 meter. Right? This is the conversion that we're using. So if you have centimeters, you want to get meters, you divide by 100. So it's 1.5 meters. Are you good at that? The question is done. Online is still there?
Yes, sir.
All right.
Yes, sir.
All right. Hope you're marking your paper and grading as you go, but this thing keeps chipping off. It keeps chipping off. It keeps chipping off. I don't know why. All right. Let's continue. Next question. Number 6. Transformation. Question said, diagram below shows triangle PQR. This is PQR. All right. First thing first, write the coordinates of the point R, which is on the y-axis, so the x value is 0. This on the scale, I can see that this would have been a 1. This is 2. This must be a 3. This right will be a 3. So the point is 0, 3, not 3, 0. 0 is the x value, 3 is the y value. So R is the point, 0, 3. Nice and easy. It says, on the diagram below, draw P prime, Q prime, R prime, the reflection of PQR in the line y equals 1. Y equals 1 is a horizontal line passing through 1. All right? A horizontal line passing through 1. So we're talking about this line. Let's draw it. This line is the line y equals 1. That red line. Y equals 1. I'm going to reflect in that line. Do your reflection 1 point at a time. So this point P first, it is 1 unit to the mirror line, going to go 1 unit to the other side to here. That's where it's going. So P is coming right here. So I'm going to put P prime here. Then this point R is 2 units to the mirror line. It's going to go 2 units on the other side to here. Go to -1. It's coming down to here. That's where R prime is going to go. R prime. At this point, it is 1, 2, 3, 4 to the mirror line. It's going to go 1, 2, 3, 4 to the other side. That's right? No, put it wrong. Start wrong place. Start from the other side. Let's go again. 1, 2, 3, 4 to the mirror line. It's going to go 1, 2, 3, 4 on the other side of the mirror line. So it's coming down to here, down to -3. All right, that's where Q prime is going. So it's coming down here. So that's Q prime is coming down here. Now that you have the points in place, you draw your triangle. That's your prime triangle. So far, so good? Yes. It's a reflection of that red line. So done this part. Next part says we have to construct P double prime, Q double prime, R double prime, reflection of the prime triangle in the line x equals 0. Now, what you must know about line x equals 0, that it is actually the y-axis. The line x equals 0 is the y-axis. So you're reflecting now the second triangle in this y-axis. All right, so don't mark it. You're reflecting now in this y-axis. This y-axis is the line x equals 0. X equals 0 is the y-axis. You have to know these things. So this is the line x equals 0. So reflecting this triangle now in that line. Now, first point, let's put this one in purple. This point is on the mirror line, so it's going to stay there. So R double prime is going to stay right there because it's an invariant point. A point on a mirror line, when you reflect it in the mirror line, stays on the mirror line. Remember, image distance must be equal to object distance. So if it's on the mirror line, then the object distance is 0. So the image distance is 0. It's on the mirror line. So this point now, when you reflect this point, so this is going to be R double prime now. This point is going to be R double prime. Let's put over here. This point. R and R double prime to the same place. Then this point now is 2 units to the mirror line. That's Q. I'm doing it now. I'm going to go 2 units on the other side to here. All right. So that's where the Q double prime would go, right here. And then this point similarly is 2 units to this line, to this mirror line. That y-axis is going to go 2 units on the other side to here. That's where P double prime will go. P double prime is going to go there. All right. And so my double prime triangle now is this one. Now that I have the points in place, I can draw the triangle. That's my double prime triangle. And you're supposed to start thinking about what happened there. We did 2 reflections over intersecting lines. These are the 2 intersecting lines. The more things you know, the better. I did a reflection in this line and a reflection in that line. Those are 2 intersecting lines. 2 reflections over intersecting lines is equivalent to a rotation. Since the angle between these 2 mirror lines is 90 degrees, then the rotation is twice that, 180 degrees. The center of the rotation is at the point of intersection of the 2 mirror lines. So the center of this 180 degree rotation will be right here where the 2 mirror lines meet. 0, 1, where those 2 mirror lines meet. So I already know that to go from this triangle to this final triangle is a 180 degrees clockwise rotation about the point where the 2 lines meet. The more things you know, the better. So don't ask me no question anything about me. I already know that. Just in case I ask that. Which more than likely they ask you something relating to that. If they don't ask you that directly, they'll ask you something relating to that. All these things are on the must know sheet that I gave you guys. 2 reflections over intersecting lines is equivalent to a rotation. The angle of the rotation is twice the angle between the lines. And the center of the rotation is the point where the two lines meet. If you never hear this again before the exam in 3 weeks' time, you have to remember it now. In case you get one like it. It's as simple as that. The lines intersect. If it was two parallel lines you're reflecting over, it will be equivalent to a translation. When the two consecutive reflections over two parallel lines, you end up with one translation. The distance of the translation is twice the distance between the two mirror lines. But these two are lines that intersecting lines, not parallel lines. So you're getting a rotation. All right? So from the original to the final is a rotation. The rotation angle is twice the angle between the two lines. The angle between these two lines, this horizontal and this vertical one, is 90 degrees. So the rotation angle is 180. Then the center of the rotation is the point where the two mirror lines meet. That's right here. Two mirror lines meet right there. All right, let's do the rest of the question though. Question said, describe fully. All right, so let me reverse it. Describe fully the single transformation that maps the final triangle onto the original triangle. It is basically a reversal of what? So this question is really asking us to reverse this, you know. So what happened is that we did a clockwise rotation to get to this. And the question is asking us how we go the other way. The question is asking us, how do we go from here to here? So we're going to reverse that single transformation. Reverse it. Or inverse it. The inverse of a rotation is a rotation in the opposite direction. Same angle, same center. So to go from this triangle up to this one, we're just going to go the opposite 180 degrees, anti-clockwise this time, about the same center right here. If you don't give all the components, you're not going to get the full marks. So because, look at it again, let us repeat one more time. Because going from this to this is a 180 degrees clockwise from the original to the final. That started 180 degrees clockwise. Rotation about this point of intersection is the point 0, 1. To go the other way, all that's going to change is that this clockwise is going to change to anti-clockwise. Can you go in the opposite way? The question is asking us to go the opposite way. See here? You go from the double prime to the original. So we're going the opposite way. So therefore, we're going to say it's an anti-clockwise. So this therefore is an anti-clockwise. See here? And anti-clockwise, clockwise 180 degrees rotation about the point where the two lines meet. They meet at the point 0, 1. We'll see it on the graph. 0, 1. 3 marks of that, guys. When you describe a rotation, you have to say the name, 3 components of rotation: angle, direction, and center. Everything is there. 3 nice marks this to get. A lot of people not getting these 3 marks in the exam. Believe me. I want my students to get these 3 marks. That's where you top Jamaica. That's where you top your school. That's where you top the Caribbean. By getting the marks where other people not get. Because you need to have that advanced knowledge. You have to waste time and figure it out in the exam. Can be figure out, but why waste time to figure out something when you can't just know it? Because it's on the must-know sheet. What happens when you do 2 reflections over intersecting lines? This question is testing your knowledge of that. All right? It don't make no sense you go in the exam room, but figure out stuff that you can know before. That's why we have a must-know sheet. All right? We have a must-know transformation sheet. All right, so that's easy. But understand this though? But understand the explanation? right? It's a reversal of the clockwise rotation that took place. So it's anti-clockwise. Also remember, guys, that anti-clockwise rotation is positive. Clockwise rotation. So if they were asking us, to go from this would be this right here would have been the description if we were going from PQR to P double prime, Q double prime, R double prime. This would have been the description, because the direction would be clockwise. You get me? And the clockwise rotation, remember, clockwise rotation can be placed as negative. Instead of positive, you can put as a negative rotation. So we could have said negative 180 degrees instead of saying clockwise. Clockwise rotation is negative. Anti-clockwise rotation is positive. And look here, a 180 degree rotation, but that's clockwise or anti-clockwise, they're giving you the same result, you know. But the reason why I'm saying clockwise here, because of this sequence of this transformation. We came this way first, and then we went that way. So that's more clockwise direction, a more clockwise orientation in terms of the sequence. But the result about 180 degrees is the same whether it is clockwise or anti-clockwise. So I don't want you all to lose sight of that. All right, but that is it. Let me zoom this up and clean this up a little bit. All right, so I'm leaving this on the screen, you know, guys, even that. I just want to make sure you understand this, you know. Understanding is very important. All right, this question says no. Triangle PQR, original triangle, undergoes an enlargement of scale factor 2. This means that K equals 2. Calculate the area of the image. No matter where the center of the enlargement is in this area we're talking about. You know. This question is testing your knowledge of the relationship between areas under enlargement. So you must know sheet. You have gone over it multiple times. If you don't see it again between now and the exam, you have to remember it today. That area of an image of an enlargement is equal to the scale factor squared times the area of the object. Scale factor squared times the area of the object. I means image, O means object. If you don't remember it before, not remember it now going forward. We did this I've done this multiple times. This question is testing your knowledge of this. Area of image is K squared times the area of the object. And K is equal to 2. And it asks us for the area of the image. So you need to calculate the area of the object, original triangle. So let's look at the original triangle. This triangle. Easy. Treat this as a base, which is 3. Treat this as a height, which is 2. 2 units. So the area of this triangle, area of the object, becomes half 3 times 2. Half base times height. This works out to be 3 units squared. This becomes 3 units squared. That's the area of this object triangle. I could identify a base and identify a perpendicular height. So basically, I need to multiply this by the K squared. All right, let me take this off. So then I go back down here then. I know the area of the object is 3 units squared. Let's write it here. Area of the object is 3 units squared. We calculated a while ago. I'll leave it here. So area of the object is half a base of 3 and the height of 2. That's 3 units squared. So this calculation gives me the area of the image equals case 2. 2 squared times this 3. That's 12 units squared. Another nice 2 marks to get. another nice 2 marks certificate. A lot of people are not going to get this 12 marks, this 2 marks. Because they don't know this relationship. But why should be in this class and don't know it? Don't make no sense. Something that we have done multiple times. But you guys have a problem remembering stuff for one single reason. Because they don't practice. When you practice, you encounter the thing repeatedly. And if I give you a must-know sheet and I give you a list and say, make sure you know these things. You don't take the time to actually try and know the things. And so something that is supposed to be quick and fast and easy for you because you're exposed to it, becoming like it is something foreign to you. It should not be the case. It's an injustice to teachers, I tell you. And someone get a question like this from my class and can't do it. It's an injustice, I tell you. Come do this, I'm going to go over it, put on a must-know sheet, put the questions on it multiple times. So there's no way anybody from this program should go in the exam, get a question like this, and act like them lost. I don't know what that's about. Should not happen. But it happens because students don't do what they're supposed to do. Understand? Next question. Number 7, statistics. This question says the marks obtained by 10 students in a test scored out of 60. This is scored out of 6. Everything important to know. Are shown below. So these are 10 scores. 2, 4, 6, 8, 10. Before we start anything, the first thing I noticed that they are not in ascending order. Once you're going to do statistics on anything, whether it is needed or not, it's good practice to ensure that the data is in ascending order. There are some statistical measures that you don't need it to be in ascending order, like for example, calculated mean. But then there are some where you need it to be in ascending order. So you can divide it up and analyze it properly. So before we even do one question, you put it in ascending order. So I'm going to write it back in ascending order first. I'm going to do it up here. On the exam paper, they don't give me a lot of space to work with. So I'm going to do it right up at the top there. Don't matter. It's a part of my answer. All right, so the lowest value is 26. Put down that first. Cross that off. Next one is 29. Next one is 31. The next one is 35. I said 3 38s there. 1, 2, 3. 38, 38, 38. Then I have 40. Oh, I leave out 37. See? So no problem. I left off 37. Let me shift these over. Put 37 inside here. Right here. Then I have 42 and 45 left. 42, 45. 42 and 45. Let me just shift this over a little bit. That's my data. It's not in ascending order. No, I'm ready to analyze. I'm not busy about this again, you know. I'm working with this up here now. 10 values. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's make sure you don't leave out any. All right, ready to analyze. First question is for the range. The range is the largest value minus the smallest value. The range equals 45 minus 26. What is that? 19. What is that? Huh? 19? 19 is the range. The range of the score is 19. 19 marks, right? These are marks. If I can put 19 marks, give it a unit. 19 marks. Range of the scores, range of the marks. Marks in a test. The range is 19 marks. So my data is in marks. Marks on a test. Next question is the median. See? This one a lot of people going to get wrong the book if they don't put it in ascending order. So the median, there are 10 marks. So the median has to be an additional mark. I must have an odd number of marks when you have the median. So because it's 10 marks, I'm going to divide the 5 and 5, and then the median is going to paste in the middle. So it's 5 and 5. 1, 2, 3, 4, 5. So I'm going to divide it right here. Let me use it ready. Five and 5. And then the median goes right in between here. Average of these two, which clearly is 37.5. That's Q2. It's 37.5. So my median is 37.5 marks. Q2 is 37.5 marks. That's my median. Next thing they want is the interquartile range. Now remember, interquartile range is Q3 minus Q1. So I need to work out those values. So I go back up to where I divide it. Now Q1 is the median of this bottom half, and there are 5 values in the bottom half. So one of them is the median. This is the median of the bottom half. This. That is Q1. Similarly, there are 5 values on the top half. The middle or median of the top half is Q3. This is the number or the score in the middle of the top half. That is Q3. So my interquartile range is 38 minus 31. Easy. 38 minus 31. This becomes equal to 38 minus 31. That is 7 marks. If I wanted the interquartile range, I would divide this by 2. And it would be 3.5. Half of the interquartile range is a semi-interquartile range. This question don't want that. Next question says, the probability that a student chose at random scored less than half the total marks on the test. What does it mean? Half the total marks. Less than half the total marks means 30 marks. That's what we're trying to find. How many persons scored less than 30 marks out of the 10? We can set up like this. The probability of less than 30 marks, of getting less than 30 marks, is to see how many persons actually got less than half the total number of marks. Total number of marks in this was 60, you know. So half the total marks is 30. You want to see how many people get less than that, right? So let's go back up here. And when it's ascending order, it's easy to see. These 2 persons got less than 30 marks. So it's 2 out of the 10. All right? 2 out of 10 got less than 30 marks. It's a nice, easy question. 2 out of the 10 students. That reduces to 1 over 5. The answer is 1/5 is the probability. But to go to that, nice and easy. Next question. It says, the frequency distribution below shows the masses in kilogram of 50 adults prior to the start of a fitness program. Just as the data is grouped, as it's 50 of them. And they've given us the midpoint values. Remember, when you can't use the group, and you want one value to represent the group, you use the midpoint value. That's how we do statistics of group data. Because everything you do in statistics of group data is estimation statistics. You can only estimate stuff. You don't know the actual weight of the 8 persons in this group who measure between 60 and 64. You don't know the actual weight. They are not presented with that piece of data. So for the purpose of analysis, you cannot do an assumption that all 8 persons in this group, you are saying basically all of them weigh 62 kilograms, which is not true. Maybe none of them weigh 62. All right? But for the purpose of analysis, a lot of times, that's what you have to do. Let's see what the sum must do. It says on the grid on page 22, use a scale of 2 centimeters to represent 5 units on the x-axis, 1 centimeter to represent 1 unit on the y-axis. Draw the frequency polygon. All the ones are frequency polygon. So the frequency polygon is like you're trying to plot a line graph. So you're going to use the midpoint values. Okay, you can't use the group values. Use the midpoint to represent the group against the frequency values. You're plotting a graph with those points. So basically using these as your points. The midpoint and the frequency. And the frequency will go on the y-axis, And the midpoint values will be the scores on the horizontal axis. All right, so those are the points. So let's write down the points that we're plotting. We're going to plot 62.8. That's going to be 1 point. 67.11. Next one is going to be 72.15. Next one is going to be 77.9. It's every 5 centimeters still, you know. You can't see that because this is going up by 5. Every 5 kilograms, sorry. This is going up by 5. So the midpoint value is also going up by 5. All right, but let's write them out still. The next one's going to be 77.9. Then it's going to have 82.5. That's this one right here. And then 87.2. Let's shift these over. 87.2. These are the points that I'm plotting. 87.2. 87.2. Remember, frequency polygon starts out like a line graph, but you have to close it. So we close it by looking at what will be the value after here and bring that frequency down to 0 to close it. So the value after this would have been 92 and that frequency is 0. That's a point to close that end at the end. Then to close at the beginning, what would be the value before this? Would have been 57. 57, and the frequency of 57 is 0 because there was no data. So including these to close the polygon. 57 0 and 92 0. For those you can see on the graph still. So I'm going to plot these points on that graph. Let me see if we can copy these down. Let's have them in front of us. Copy. Paste them over on the graph. So this is the graph here. Them must use 2 centimeters to 5 on the x-axis, right? Which is where we're going to put the midpoint values, or the kilograms, the mass in kilograms. So 2 centimeters to 5. Let's scale it up down here. So like this is horizontal scale on here. It's 2 centimeters to 5. So this will be 5. 5, 10, 15, 20, 25. By the way, I don't do that right now. Scale can't start at 0, can't start at 5. So the value start at this, you can't start at 10. You have to break the scale. I have to break the scale and at least start at a value before 57. I mean, we have to close it now. So we'll start at 55 instead. All right, can't start at 5. So that's another thing you have to realize. So we'll start at 55. Let's start at 55. Can't start at 10. So we'll start right here at 55, 60, 65, 70, 75, 80, 85. Went up 2 again. Last value was what? Last value was 92. So going up to 95. 90. Or to 95. All right, makes sense. Then the y scale is what? 1 to 1, them say? The vertical axis, 1 centimeter to 1 unit. Yes, 1 to 1. So if it's 1 to 1, then this will be 1 and this will be 2. So we can go 2 to 2, same thing. So it's gonna go 2 to 2. So we're gonna go 2, 4, 6, 8. What was the highest value again? I wanted to pass 10. Highest value on the frequency was 15. Up to 15. All right, so we're going up to 15. 10. This will be 12. 14. This will be 16. So what we're going to do now, we're going to put mass down here in kilograms. Up here, we're going to put frequency, or number of persons, right? Up here is a frequency. Those are students again, or adults. Those adults, right? 50 adults. You can put number of adults, or you can put frequency. Up here, you have your adults. Or your frequency. number of adults, so frequency. Frequency. All right. And you're basically plotting these points. Plotting these points. Or you can say you're plotting these values. Let's memorize them. So the first value is 8, 11, 15. 8, 11, and 15 are the first three values. 8, 11, 15. I was starting at 62. And it's ever 5. Let's put where the mark gonna be. 62 was the first mark. All right, so where would 62 be? That's the next thing. Let's do that part in blue. So this should be 61, 62, 63, 64, 65. So this should be 62. All right. And then 5 more is going to be right here. So basically 2 after every mark, you put it's going to be 5. This should be 62, it should be 67. So those are the lines that you want. So basically every 2 marks after every mark. Two lines after every mark. That's where you're going to put your scores on those lines. All right. And then you're coming right here as well. For 0. Or this will be 57. This is 62. This is 67. All right, let's look at the values now and do this thing. So the first 3 values are 8, 11, and 15. 8, 11, and 15. 8, 11, and 15. All right, so this first mark, remember, start at 62, coming up to 8. Right up here, coming up to 8, right here. Then 11 is going to be on this line. 11 up on that line. So right here is going to be 11. Next one is going to be 15. 15. So now up on this line. This one. I'm going up to 15. Going up to here. All right, so the first 3. Let's look at the next. We can say that this is going to close down to 0, right? This end is going to close down to 0 at 57. You said that, right? Close down to 0 at 57. See it here? Close down to 0 at 57. So we can put that in. So we're going to close down to 0 at 57 right here on the x-axis. And the next 3 values. Next 3 values will be 9, 5, and 2. 9, 5, and 2. 9, 5, and 2. So the next mark is here, going up to 9. Or 9 is right here. Right here is 9. So 9 is so we're talking about right here. 9, 5, and 2. So this is now one that will go up to 5 right here. This is 5 over there. So we're talking about this point, 9, 5, and then 2. So this is the last value now. Sorry. This is 87 going up to 2. 2 here. Talking about right here. Right? And then you have to close it. Close it down to here now, down to 0. Remember? 92, 0. Let's look back at it. 92, 0. See there? 92, 0. Close it. You have to close the polygon. 92, 0 is right here. So those are your points. So all you have to do now is draw a ruler and draw straight lines between those points. The ruler. Straight lines between those points. So let me show what you would originally have before you close it. So before you close it, you'd have a straight line here. Then a straight line here. This highest point, yes. Then you'd have a straight line here. Then you'd have a straight line here. Then you'd have a straight line here. That's what you'd have before you close it. That's not a polygon. That's a line graph. You have to close it. So you close this end out here. Down to where the next value would be, you bring it down to 0. And where the first value would be, you bring it down to 0. Down here. And that is how your frequency polygon should look. Are you good? All right, beautiful. Now let's continue. That finishes this question. All right. Next question is our pattern. It's supposed to be a 5 minutes makeup time question. All right. So like you reach critical junction in the paper, you want to make up some time. This is the question. Can be done in like 5 minutes or less. All right. Question says the sequence of figures is made up of toothpicks of unit length. The first 3 figures in the sequence are shown below. All right. So what it is like they're adding on one of this to each thing and then cross put in another, completing another triangle on the top. So to draw the 4th figure, then I have this one and I need to put another triangle on it. So I put another triangle on it like this. To draw the 4th figure, put another triangle on it like that. And then just close the top like that. That's going to be my 4th figure. Good? All that should be my 4th figure. But I'm going to just finish it up with the device and help myself. So it's a line and a line and a line. And I have these toothpicks under here. Maybe it's supposed to have like toothpicks in it. So it's supposed to just have a little gap between it like that. And when I put everything here together, I'm going to have my figure number 4. Let's move this down. It's going to be my figure number 4. So that could be too long. That's it. Figure number 4. All right. As I said, I noticed in recent times what they will do, they draw the figure number 3 down here for you and ask you to add on to make it figure number 4. That's what I see them do the last couple of times. So I'm suspecting that they'll do it that way next time rather than ask to draw everything again. All right, question says now, study the pattern of numbers in each row of the table below. Each row relates to one of the figures in the sequence of figures above. Some rows have not been included in the table. Complete the rows numbers 1, 2, 3, 4. All right, so I want to see complete the formula row first, as usual, because sometimes it helps to find the other figures above. Look at this column here, it's increasing by 4. Increasing by 4. So 4n is a part of the formula because it's increasing by 4. So it starts out at 4n. But the first figure only has 3. 4 times 1 is 4. I have to subtract 1 to make it 3. So minus 1. And this column knows a formula. Let's look at it carefully. So the first value is always changing. It's always 1 less than the figure number. So that's n minus 1. So it starts out n minus 1. Plus, then the second figure is always the figure number. So it's n minus 1 plus n. N minus 1 plus n. And then the third figure is always a plus 2. Always a plus 2. Plus 2. And then I put it equal something. Let's make this smaller. Then put it equal something. So what would this be equal to? If we write this out, this will be equal to n plus n, which is 2n. And then minus 1 and 2 is plus 1. So that's 2n plus 1. So this is 2n plus 1. I can maybe see it here too, you know, because these numbers, no, it's not 2n. Yeah, these numbers going up by 2. Yeah, it's true. They're going up by 2. So it's 2n starts a formula, but the first value is 3, 2n plus 1. All right, good. So that confirms it. 2n plus 1. All right. So now that we have that, we're good to go. This one, easy. Either we add 4 to this because it's the next shape, or we can take the 4 and drop it down on this. 4, 4 is 16. 16 minus 1 is 15. Right, here's 15. Then now, filling out this row now. So it's going to be start with 1 less than this, which is 3, plus this figure itself, which is 4, plus 2, and it's supposed to work out to be, it's not right. 7, yeah, it's right. 7, 2, 9. Yeah, 9. It's supposed to be 2 more than this. Good. That's 9. Then this one now. This clearly is figure number 20, because the number in the middle is always a figure number, right? So for this one, it's figure number 20, but the figure in the middle is always a figure number. So right here is 20. And then now, I'm going to take the 20 and drop it down on this formula. 4 times 20 is 80. 80 minus 1 is 79. So that is 79. So right here is 79. All right. Then this one knows when this equals a formula. So it's when the formula equals 127. I want to put that value here. So it's when 4n minus 1 equals 127. Add 1 to that, we get 4n equals 128. So n equals, what is that now? 32 that? That's 32. Don't it? 4 times 32, now 128. So that's 32. So it's figure number 32. I'm going to drop this over here now. So this is now always 1 less. You start out at 31. Plus then the figure number, which is 32. Plus 2. And this works out to be what now? This works out to be 63 plus 2, which is 65. That's it. I could drop the 32 on this formula. 2 times 32 is 64 and 1, 65. Question done. Next question, number 9. Question says, show by calculator, the exact roots of this quadratic equation are these. All right, so this is just this guy using the quadratic formula to get this. That's all. These are the roots. So the roots would be, let's just go straight into this. A quadratic equation now. And the roots would be using a formula that says x equals minus b plus or minus square root of b squared minus 4ac all over 2a. That's what we're using. All right? So already know. So down here now, the x is going to be equal to minus b. The b's are 2. There's minus 2. Plus or minus. Plus or minus. Square root of b squared, which is 2 squared. Minus 4 times a. The a of that coefficient is 1. Times c. The c is negative 5. Everything, all over 2a. The a is 1. That's what we're working down. So this works out to be equal to, this remains a negative 2 plus or minus inside here now. This becomes a positive 20. But minus give a plus. Positive 20 plus this 4, that's 24. Square root of 24 all over this 2 times 1 is 2. That's still over 600 square root here, so. I'm going to factorize this 24 into 4 times 6. So it's going to become x equals minus 2 plus or minus the square root of 4 times 6 to get the 6 that I have in the answer right here, divided by 2. Continue right here. Now this square root of this under here is same as square root of 4 times the square root of 6. But the square root of the 4 is 2. So therefore this then can be written as x equals minus 2 plus or minus square root of this 4 is 2. So you get 2 times the square root of a 6 back. Square root of 6 over 2. And so x then becomes equal. Divide each of these now by the 2. We divide this by this 2, you get -1. You divide this now by the 2 cancel. That is here. You give me plus or minus the square root of 6. And therefore shown. All right. I don't think this was a good question for this paper whatsoever. After what is in front of you. All right. I think some people would have gotten maybe down to here. I will put this in the calculator, guys. Some calculator can give you this in search form. Some calculator can give you that. So maybe if you work down to here and then write that, they would know that to use a calculator. I could say using a calculator. I get that. But if you can do all of this full process to get it down to this, all the better. All right. Let me put this formula in a different color that we used. Let's put that in red or something. All right. Next question says, it says, hence or otherwise, solve the simultaneous equation, this pair of simultaneous equations. We're going to use a substitution method. Since this has y as a subject, we're going to use a substitution method. We're going to take this, y is equal to this on the line. This is the line and this is the curve. This is the line and this is a curve. So it's like the line go like this. What is this? Y equals x plus 2. So the line go like that. Xy equals 5. Y equals 5 or x. It's supposed to be 2 points of intersection. 2 points of intersection. Y equals x plus 2. Xy. Y equals 5 over x. Y equals 5 over x. It's supposed to be a curve. I'm thinking that it is shaped like this. Which has shown me 1 point. Anyway, don't worry about that. But anyway, so I'm solving them sandwiches. I'm going to take the line, or the line say y equal to, and put it in the curve right here for the x. That's what I'm going to do. All right, let me write them over. And show it. So I'm going to take 2. I'm going to write it instead as, write this line as y equals 2 plus x, or x plus 2, same difference. And the curve is xy equals 5. I'm going to substitute the line saying y is equal to that. Put it here in the curve for the y. That's what I'm going to substitute for the y. Using a substitution method. All right, so I'm going to sub the line equation into the curve equation. I'm subbing for the y. And then when you do that, when you make the substitution, you're going to end up getting that x times x plus 2 equals 5. Because where this x is, we replace it with the x plus 2. With the y, I mean is. All right? And if you expand this now, you're going to get x squared plus 2x. This 5 come over here, become a -5 equals 0. And this is now the same equation that we had up here. That's what the question said, hence. Same equation, you know, see there? So you already know the 2x values. One with the plus and one with the minus. So you already know the 2x values. So solution for this one, so you can say, therefore, x equals -1 plus, the first one was √6, right? Or x equal -1 minus √6. See, that's the plus or minus here now. From the original question. Plus or the minus. One answer with the plus, one answer with the minus. One root to the plus, one root to the minus inside here. That's what I've done here. I've separated them. So this is one root, that is the other root. Plus or minus, break it out into 1 for plus, 1 for minus. Right? But the question says I must solve them, so I need to find the y values. So to get the y values, I'm going to substitute them in the line equation. That has y as a subject. So I'm going to say I'm going to sub into y equals x plus 2. First value. For the first value, for this first value, this first one, I'm going to get y equals minus 1 plus root 6. That's what the x is. Plus this 2. Then this and this give me 1. So y equals 1 plus square root of 6. And then for this value, and I substitute this one in this equation as well, and put this in red so we can see what we're subbing into. Put that in a different color. All right. So the second one, this one now, when I sub it in this line, I'm going to get y equals, this becomes my x, minus 1 minus root 6 plus this 2 plus 2. So we get y equals, this and this now gives me a positive 1. So I get positive 1 minus root 6. Minus root 6. So those are my x and y values. But because them says so, I'm put them in brackets, right? Like coordinates. So one pair of values, I'm going to write this as my solution line now. One pair of values would be this x value and this y value. Minus 1 plus root 6. Minus 1 plus root 6 is my x value. This is my y value. 1 plus root 6 is my y value. Then for this pair, this and this, other pair, bracket, this is my x value. Minus 1 minus root 6. This is my y value. 1 minus root 6. So I'm leaving these as my answers right here. Leaving these as my answers. This as my answers. Kind of cumbersome, but that's how it is. You have to answer what they get on the paper. Yeah, that is it. All right. Next question. Next question gives us the incomplete table below, shows x and y values for y equals 2 to the x. Y equals 2 to the x. I want us to fill these out. All right, easy. So the first value here is 2 to the minus 1. I'm write them out. Minus 1. I'm getting y equals 2 to the minus 1, which is 0.5. It becomes a half. So this will work out to 0.5 if you work it out to the calculator. 2 to the minus 1, that's here. Then for 1, you're getting 2 to the 1. Right? For 1, the y is going to be 2 to the power 1, which is 2. You're getting a 2 right here. For this one, for 2, the y is going to be, these are the x values now. The y is going to be 2 squared, 2 to the 2, which is 4. It's going to be 4. Then for out here, when x equals 4, the y is going to be 2 to the 4th power, which is 16. This is 16. So this value is 16. Those are your values. Those are your values. It's a complete table, so we have done that by just putting in the x values and the formula here, where the x is, all of them. All right? These are the calculations. I'm going to write this better. This is 0.5. 2 to the minus 1 is 0.5. Because 2 to the minus 1 means 1 over 2 is a half 0.5. That is it. Even though you keep multiplying by 2 to go up this way, right? Keep multiplying by 2. Then it says, no, on the grid on page 17, draw the graph. So to draw the graph, you're basically plotting these points. All right? Draw the graph using a scale of 2 centimeters to 1 unit on the x-axis and 1 centimeter to 1 unit on the y-axis. All right, so we're drawing that graph on this grid. All right, let me suppose use on the x-axis 2 centimeters to 1 unit, 1 centimeter to 1 unit. All right, so let's start it first. 2 centimeters, 2 centimeters to 1 unit on the x-axis, 2 to 1, and 1 to 1 on the y-axis. All right, so this is going to be 1, 2, 3, 4, 5. It's going to be negative 1. Then on the y-axis is 1 to 1, so it's going to be 2, 4, 6, 8, 10, 12, 14, we have to go up to 16, 16, y-axis, x-axis. All right, let's put the points in blue. So the first point was negative 1/2 and then 0, 1, negative 1/2 and then 0, 1. Can put in all the points and just keep multiplying by 2 to know the values, you know. Can do that, you know. First value is 1/2 and then keep multiplying by 2. Negative 1 is 1/2. So negative 1/2. This is 1/2 will be right here. So right here is negative 1/2. All right. So we're talking about this point right here. Then we have 0, 1. Multiply the half by 2, you get 0, 1 right here. Multiply by 2 again, you get 1, 2. Multiply by 2, 2 times 1 is 2, we get 1, 2. Multiply by 2 again, 2, 2 is 4 up here. Multiply by 2 again, I get 8. 4, 2 is 8. 2 cube is 8. 2 cube is 8 right here. And then 4 give you 16. 4 give you 16 all the way up here. I multiply 8 by 2. So 4 giving you 16 all the way up here. So those are your points. And draw a smooth curve through those points. So I'm going to draw a smooth curve to those points. And it's going to go like so. And it's a curve you must draw now. Don't put a ruler on it. It's a curve. Don't use rulers on curves. All right. That is it. Those are my points. All right, next part now says, by drawing a suitable or an appropriate, sit here, by drawing an appropriate line on the graph, determine the value of x where 2y is equal to 11. 2y, remember the 2 to the x is equal to 11. Because the 2 to the x is really y now. So basically, I have to draw a line y equals 11. Trying to find where the y value is 11. So this is the line we have to draw. Line to draw. Put another way, it's quite simple. If you want to know where the curve equals 11, the curve is 2 to the x. You have to come up to 11 on the y-axis. So line to draw is the horizontal line to 11 to see where the graph meets, where the graph y value is 11. So see 11 here. This is a different color. This is red. This is 11 right here. This is the point where it will be equal to 11. All right. So you come across on the graph here. And system to draw that, I'm going to extend it out and show the line y equals 11. Y equals 11. So at this point, the y value is 11. You want to know what the x value at that point, you read it down on the x-axis down here. Use your ruler and do it. That looks like about 3.5 and I get? All right, 3.5. Can test with the calculator now, see if 3.5 is a good answer. Let's see. I can tell what the actual answer is supposed to be by taking logs. You can take logs and tell what the actual answer is supposed to be. Let me see, 2 to the 3.5. I see what I get. 2 to the power 3.5. get more than 11. Let me try my answer. I'm saying 3.45. Just on my graph, see there? I'm saying 3.45. Let me try 3.45 and see if we get any closer. Closer. My answer is closer to 11. I'm going to write 3.4. If you put 3.5, I'm going to get the marks still, you know. But I'm going to put 3.45. Trust me, if you put that, they'll give it the marks. They will give it the marks. This is x equals 3.45. That's what my graph gave me, even on this device, 3.45. So I'm going to write that up here. 3.45. X equals 3.45. Because that gives me 10.9. That's closer to 11 than if I put 3.5. But that's 11.3. It's further from 11. But if I put the 3.5, they give the marks. So that's what they did, get the marks. So no problem. All right? Let's continue. We're about to work out what the actual value is supposed to be. Let's just continue. That's what you do. Next question. I think I'm going to go a little bit quicker on these questions now. All right? This question says, diagram below not drawn to scale shows a circle center O. The points A, B, C, and D are on the circumference. That means they have a cycle quadrilateral. EAF and G are tangents. So these are two tangents. These are two tangents out here and out here. So that they're going to be equal in length up to the point where they meet the circle. So this length and this length are going to be equal in length. So that's an equal, that's an SSC triangle. All right. Bam, bam, bam. A and D respectively. Angle AO as angle at the center of the circle 114. Angle CD. C is angle between here. That's angle between the tangent and this chord is 18. So it means that the chord subtends 18 as well. That's some information you know. All right, so I can give you AC to D to C to D. All right, let's look at it now. So they're asking us for this angle, ACD. So that angle is subtended by this chord. See? ACD is subtended by this chord. This chord. What is the chord doing? It's subtending 114 at the center. Same chord, you know, that is subtending. This angle at the center is subtending the angle that we want at the circumference. One circumference is half the one at the center. So the angle is going to be half of 114 degrees. Because angle at the center is twice angle at circumference. Half of 114 is how much? 57, right? 57. So that angle is 57 degrees. Let's mark it. Right here is 57 degrees. $57. Half of the 114, but both of them subtended by this chord, right? Let's write that. This angle becomes half of 114 degrees, which is 57 degrees. Why? Because the angle at the center is twice the angle of the circumference. See here, angle at center is twice angle at circumference. Angle at center of a circle is twice angle circumference. The angle circumference is half the one at center. Next angle I want is angle AED. Let's see where that is. Angle AED. Angle AED. Angle AED. Where's the E? Oh, down here. Angle AED. That's the angle between the two tangents. Remember now that the angle of the two tangents and the 2 radii is a cyclic quadrilateral, right? So these two angles across here add up to 180 degrees. They are supplementary. So this angle that I want down here is 180 degrees minus a 114 degrees. 180 minus 114 is how much? Huh? 66? 66 degrees. All right, let's do that. So it's 180 minus 114, 66 degrees. Let's put it there. So this angle inside there says 66 degrees. All right, that's because these two must add up to 180. Let's write that, 66 degrees. So this angle equals 180 degrees minus 114 degrees, which is 66 degrees. What is the reason? Two tangents and the two radii are cyclic quadrilateral, or you can just name it. OAED is a cyclic quadrilateral. Just tell them that. OAED is a cyclic quadrilateral. Opposite angles are supplementary. Let's say that. OAED is a cyclic quadrilateral, and the opposite angles are supplementary because it's cyclic. Supplementary. And supplementary simply means that they add to 180 degrees. That's it. 66. Next angle I want is angle OAC. Let's look at that now. OAC, where is that? OAC. All right. OAC now is this angle between here. OAC. Let's take a thin angle between there. So, all right. Let's see how we can get that angle now. This is a piece of one to know. All right. To get that one, it looks like we can find the whole of this and subtract it from this one in here. That's how we can get that one. All right. Now, firstly, the one in here in purple is subtended by this chord. See it? That chord is subtending that one. The chord is making an angle of 18 degrees with the tangent. And so the chord subtends the same 18 degrees. So that purple angle is 18 degrees, tangent and chord rule. I'm going to write it here now. That angle is 18 degrees. Let's put it. This angle is 18 degrees. This purple angle here is 18 degrees. Why is that? Angle subtended by the chord that is making an angle of 18 degrees with a tangent. All right, let's write it. Angle between tangent and the chord equals angle subtended by the chord. That's why that angle is 18 degrees, because of that rule, for that reason. Then now, this red angle now, let's use a different color. This blue angle now is one of the angles in this isosceles triangle. Them two blue angles here equal. Right? Them two blue angles here equal. They are half of the 66 degrees, because it's 180 minus, that gives us a 66 and it's half. So each of them is 33 degrees. So I'm going to say that the blue angle over here, which is also equal to the same angle on the other side. So this blue angle and this blue angle is the same, them equal, isosceles triangle. So this angle here becomes 180 degrees minus the 114 degrees, which is 66 divided by 2, which therefore is 33 degrees. 33 degrees, right? So therefore, the red angle becomes the 33 minus the 18. See that? Red angle becomes the 33 minus the 18. So the red angle in here that I want now, this red angle inside here that I want becomes 33 degrees minus the 18 degrees. How much is that? 33 minus 18 is how much? How much? 15 degrees. That's my answer now. And I'm leaving these as on my paper. I'm just going to write the 33 minus 18 down in the answer section. I'm leaving those as my answers, as my reason on the paper. So this becomes equal to, what you say? I'll go on this up. Becomes 33 degrees minus the 18 degrees on my paper, which is 15 degrees. And the reasons for total angle. Total angle. And C diagram. C diagram. All right. Tell them to look on the diagram to see them something on the right. See them here? See the diagram for what I wrote. See the diagram. I wrote what I did. All right. Next one. Wants me to calculate angle ABC. Angle ABC. Where is that now? That is this angle right here. All right. So that angle right there is sub 10. You can do the angle the two ways now. Watch this now. Watch this now. Show you something now. Let's use a green and show you something. All right. Firstly, this angle, we can find it if we calculate this angle across this, all right? Don't it? 180 minus. Those two angles add up to 180, right? Good. So how can we find this angle down here? How can we find this one? How can we find this one? Because we have these two angles in this triangle. Get the 180 minus those two and get this one, yes, right? Agreed? And then to get this angle away. Let's just do it that way first and show you. So this green angle down here, let's do it. This green angle down here is 180 degrees minus the sum of these two inside the triangle. Inside this triangle. 18 and 57. 18 and 57. So you're subtracting the 18 degrees and the 57 degrees. What is work out? Somebody write this out for me. What I work out to? This angle will equal the same thing, you know. 18 plus 57. Eh? Understand that? Huh? 18 plus 57. 57 degrees. Eh? Eh? 75. And then since this angle over here says 75, then this one over here is opposite to it, becomes 180 degrees minus the 75 degrees. Because opposite angle, that's a 75 that look what that look wider than 75. Anyway. And a 75, 175. 175, you say? Huh? 180 minus 18 and 57. 18 and 57 is how much? And you subtract from what? 105. 105. 105. Let's have a look right. And then up here now we're doing 180 minus 105. 180 minus 105. This gives us back that 75 degrees as well. All right, so we're saying it's 75 degrees. But let me show you another way we could have gotten it. Let me show you another way we could have gotten it, right? So I showed it that way. Let me show you another way in a different color. Let's use a red ink again. Now see this angle up here that we want? What is now? Now? This angle up here that we want. Bring it another way in red. It's subtended by this chord. Okay now? Subtended by that chord, right? Agreed? That chord will be making this chord that is subtending that angle that we want up there. we're making this total angle across here with this tangent. This tangent out here. So it's the angle between, it's the angle inside here, so between this tangent and this chord equals the angle up here, so. The question is, what is this red angle down here? So what is that angle? We know piece inside so has 18 already. What is this little piece right here? What is this little piece inside here, so? If you think of this as an isosceles triangle, then this angle inside here becomes 180 minus this 66 divided by 2. 180 minus 66, 140 divided by 2 is 57, don't it? 57, don't it? So this angle becomes 57. And shift this over. I'm not sure another way you could have done it. Don't want that. Divided by 2, this becomes 57 degrees. So now remember, this red angle now is 57 plus 18. 57 plus 18 is the angle between here. The 57 degrees here, so, plus the 18 in there, so 57 plus 18. So the angle subtended by this chord across here is also 57 plus 18. So this angle here, doing it another way, would be 57 plus 18. It's give you the same 75 degrees. So you could have done it that way as well. Tangent and chord rule. But it is 57 plus 18 degrees. All right? Could do that way as well. So let me go and write it. Let me go and write which method we use it. Let's go on 57 plus 18. Tangent and chord rule. So this angle that we want up here is equal to 57 degrees plus 18 degrees, which is 75 degrees. Angle between tangent and chord equals angle subtended by the chord. Now, if you do it another way and get the same answer, no problem. Because there are multiple ways it can be done. If I do this question another day, you're going to do the same angle 5 different ways. So if you do it another way and get the angle, it is 75 degrees. That last angle. If you got it another way, fine. I think most persons will try to do it in green. Where they would find this angle across here is a first, and then 180 minus it to get that one angle. I use cyclic quadrilateral. All right? But whichever way you do it to get the answer, that's fine. All right, let's continue. Don't you have this box? Do this question already, you know, I remember it. It says, the diagram below shows a cuboid and it shows those dimensions. Give our answer correct to 1 decimal place. It says a straight adjustable wire connects R to P. That's across the top here. All right? Along the top of the cube. I calculate the length of the wire. So it's going to be on this triangle. It's hypotenuse on this triangle. Where over here is 100 centimeters as well. Just like here. So using Pythagoras theorem becomes the square root of 100 squared plus 60 squared. All right, so we can write that. RP is the square root of 100 squared plus 60 squared. What I work out to? Huh? 117, 117, to 1 decimal place. Come to 117 exact. Let's say 1 decimal place enough. Follow instruction. Let's see. Let's follow. Let's say 1 decimal place. Let me see what I get. Square root of 100 squared plus 60 squared. Them say one decimal place. You have to put 116.6. The question say one decimal place. Give your answer correct to one decimal place. So you have to put 116.6 for the instructions. Centimeters. All right. That's what the question. So one decimal place. It says now the point P is now adjusted to R. So this point P on the wire is now adjusted to R. Calculate the length of the wire now, RT. So see it here now. So the wire now is now from here to here. So diagonally across the box down to here now. Let me use already. Let me see it better. So we're coming down here now. So what's the triangle on that one now? The right angle triangle again, you know. It is this 20 centimeters plus the 100 and the 117 or 116.6 so that get up here. That becomes the right angle triangle now. So that is 20 over here and 116.6. Pythagoras theorem, I'm gonna give it that red length again, using the 116 and the 20. Get that red length, the RT. 116.6 and the 20 forms that right angle triangle. All right, so let's do it. So this RT is gonna be the square root of 116.6 squared plus 20 squared. The question said one decimal place. So RT equal, let's go. Square root of 116.6 squared plus 20 squared. I'm getting 118.3. 118.3 centimeters is the length of that red wire now. All right, what else I want us to do? They now say calculate angle TRV. TRV, where is that now? Angle TRV. TRV, let's mark it out in purple. Angle TRV. So TRV will be right here. I can mark it out in the red because that's part of the red line. TRV. So it's basically the angle here. It's TRV. See there, TRV, that angle there. But if you look here at Z, up back to this line, so this Z, if I draw back this red line, it's also this angle. So basically, I can come and work in this triangle that I have here. I'm now marking out in red. I will try to find this angle. In that case, over here is the opposite, and this is adjacent. But this line across will be the hypotenuse, working in that triangle there. I'm leave the triangle alone on the screen. See that triangle there? That red triangle? That's what we're working in. Up here says 116, and over here says 20, and we're trying to find this angle. Because that angle that they want is the same angle over here, so you know. Using the Z angle. This angle and this angle is the same, alternate. All right, so we're going to use the 116 as the opposite, 20 as the adjacent. This side is the hypotenuse. It is opposite the 90. The 90 will be right in this corner right here. So you have to consider 3 dimensions. So we're using 116 as the opposite, 20 as the adjacent. We're using tan. All right, we're going to call it Come on, something. All right. All right, guys, we're back. Back online. Online, we're back.
Yes, sir.
All
Yes,
right.
sir.
That's all like on the tired. Tired. Can't tired at exam time. I'm mad. Right. So it's over 20. Right? Back to it. We're working on this triangle right here. I wanted this angle over here. Look at it again. I wanted this angle here, which is a Z angle. I'm going to find the one inside there instead. I'm going to use the opposite over the adjacent and use tan to find this angle. And that's right angle triangle. All right, so use tan equals opposite side of that over the adjacent side. And then the angle is going to be tan to the minus 1 of that. The theta is going to be tan to the minus 1 of the 116.6 over the 20. We'll work that out to get the answer. So it's tan to the minus 1 a fraction 116.6 over 20. That is 82.3. 80.3, sorry, 80.3 degrees. 80.3 degrees. Next question. Compute the following statement. The size of the angle through which RP move to RT, to which it moved from RP to RT. That angle they're asking for now is this angle right here. Let me see if I can just draw back these lines a little bit cleaner on this diagram. So remember that we moved from this line across here down to this line down here. So the angle you moved through was this angle here. So and we have this angle here. This angle here so is 82 point something. Total angle in this red triangle now is 180. This angle here so is 90, you know. So the angle over here that you want and angle down here must add up to 90. So the angle through which you move through is 90 minus the 80.3 degrees. 90 minus 80.3. All right. So we just need to subtract from 90 up here. We're getting 9.7 degrees. So the angle through which it moved through is at 7.3 degrees. 9.7 degrees. This is 9.7 degrees, which was the 90 minus the 80.3. That's the angle through which it moved through. Give it this answer. Then say no. The angle which is the same as RTV. Which angle is the same as RTV? Now, RTV, remember, is this angle under here, so you know. The angle that is the same as it is this one here that we calculated, which is PTR, sorry. Angle PTR. Because of the Z angle right here, the Z angle. You can see the Z right there. PTR, Z. That's not this thing not drawing straight lines so well. PTR. Right? PTR is the angle that is the same. PTR, Z angles. So it's going to write angle PTR. Those two angles are the same. Z angles are equal. That is it. Then we'll come to what? The last question of the day. What time is it? After 2. Let's finish this one quickly. Question says, they give us these two vectors, well, 3 vectors actually. I want us to find OQ. Look, they give us OP and they give us PQ. You know? So this one kind of easy. You know? We go from O to Q. We can go from O to P first, using this OP, and then just add this PQ. Go from P to Q. Simple as that. Go from O to Q based on what they gave us. We can go O to P and then go from P to Q. So the answer is just to add these two vectors. Just add them. So it's 3 and minus 1 is 2. 4 and 2 is 6. That is the answer. Nice and easy. 2, 6. All right. Next question. Show that OQ and RS are parallel. One is a multiple of the next. Let's look at it. This is the big one. This is OQ now. This is a bigger one. OQ. This is clearly 2 times that. See it? Which means that they're parallel. Eh? This OQ, it is clearly 2 times this. The big one is 2 times the small one, which means that they're parallel. So that's right. OQ is clearly 2 times RS. 2 times RS. These are the numbers. OQ is 26, RS is 13. So OQ, which is the big one, is 2 times the small one, which is RS. This means that they're parallel. Therefore, OQ is parallel to RS. This is a symbol for parallel in maths. Simple as that. By getting this equation, one is a multiple of the next, it means that they are parallel. Simple as that. This means that they are parallel. Next one. They give us they say XYZ is a triangle and M is the midpoint of XZ. But guess what? They don't show no triangle. I want to have a visual to see what I'm doing. So I'm just going to draw a random triangle. Any triangle. I just put the points on it, X, Y, and Z, and then put on the vectors. I'm just going to draw a triangle to help me. I'm going to put X right here, Y right here, Z right here. I'm going to put on the vectors on this triangle that I've drawn. So X, Y is A. So this vector up here is A. And then, first let's say B is the midpoint of XZ. So XZ here, so not B, M. M is the midpoint of XZ. So I'm going to put M right here, XZ, right? So M is right here, so M. M is the midpoint of XZ. Oh, but they said YZ is B. Let's put that on the diagram as well. YZ is B. Put it right here. Y down to Z is vector B. So it's easier when you have a visual of what they're telling you. And just draw a triangle and put them on. All right? Then the question says now, calculate XZ to go from X to Z. Clearly, you're going to come up A and then go down to B. There's A plus B. Simple as that. A plus Z. Based on this diagram, A plus B. So this is equal to A and then B. Simple as that, to go from X to Z. Then I want MY. Look at the diagram. How do we go from M to Y? Now remember now, we now know this vector now. We now know this vector because we have it. It's A plus B. Right? To go from X to Z is A plus B. And we're trying to go now from M to Y. From M to Y. Look at the diagram. So from M to Y, you can go from M to Z here first, and then go from Z to Y. Let's write it. We're gonna go from M to Z, and then go Z to Y. But see, the M to Z is half of the XZ that we just calculated, you know, because M is the midpoint. So this MZ is really half of this side. So this is really half of the XZ. And you're adding back the ZY based on the diagram. So half of the XZ is just half of this. So it's just going to be half of A and half of B. And then the ZY right here is actually minus B because I'm going in the opposite direction to the B. So the ZY is really minus B. See? And that is it, you know. This is the only A value there. So that is half A. And then half B minus a B give me minus half B. That is it. Minus half B. So it's half A minus half B. Gives you MY. Simple as that. All right. What else? Next question. Next part is our matrices. This question says A and B are these two matrices. The one first is the inverse of A, inverse of this matrix. Remember, A to the minus 1 is 1 over the determinant of A times the adjoint of A. So it becomes equal to 1 over the determinant. The determinant is this product, first diagonal product, which is -2. See, because that's -1 times 2, minus the second diagonal product, which is 3 times 0, which is 0. They multiply that now by the adjoint of A. So you interchange these two elements on the first diagonal, switch them around. So you get 2, -1. Then leave these two other elements on the second diagonal where they are, change the sign. 0 don't have a sign to change, so that stays 0. But this +3 becomes a -3. Then this under here really is a -2, let's put it. This under here really works out to be -2 because -2 minus 0 is still -2. So you basically now dividing each of those values by the -2. So this divided by -2 is -1. This divided by -2 is 0. This divided by -2 becomes a +1.5. 3 over 2 is 1.5, 1.5. So you're getting 1.5. And -1 divided by -2, negatives cancel, give you a half, which is 0.5. So this is the matrix right here, a to the -1. Next part now says, show that a to the -1 times a equals I. We have to remember that the I matrix is 1, 0, 0, 1. So that's what you're trying to prove. You're multiplying the inverse and the matrix. So the inverse is this. Because of these values, we can work with it, right? So you're multiplying the a to the -1, which is -1, 0, 1.5, 0.5. You're multiplying that matrix by a. And the a matrix is this one. -1, 0, 3, 2. -1, 0, 3, 2. And you're multiplying these two matrices. You have to kind of show some work. You have to show it equal this when you're done. All right, so let's put it here. So equals 2 by 2 matrix. And it's going to work out to 1, 0, 0, 1 in the end. We know that. But let's put the work in now since I want it. Right? We have to show the work in now. Multiplying the rows of the first matrix with the column, getting 4 values. First value here is in the first row, first column. So to get it, to multiply this first row with this first column. First element times first element, second element times second element. First element times first element, second element times second element. -1 times -1 and 0 times 3. -1 times -1 is a +1 and the 0 times 3 is 0. So you get 1 plus 0. So you see this final value is 1 in truth. Then now, this value out here, this is in the second row, this is the first row, sorry, second column. First row, second column. This first row times this second column. Ready? First element times first element, second element times second element. First element times first element, second element times second element. -1 times 0 is 0, 0 times 2 is 0. So this is 0 plus 0. So you see the final value out here is actually 0. Then now we come to this value here, which is in the second row, first column. So multiplying this second row with this first column. Same thing again. First element times first element, second element times second element. First element times first element, second element times second element. 1.5 times -1, 0.5 times 3. 1.5 times -1, 0.5 times 3. 1.5 times -1 is -1.5. 0.5 times 3 is +1.5 plus 1.5. Let's put them above each other. So it's -1.5 plus 1.5. So you see these give me 0 right there. And then the last value down here now, that we want down here, it is in the second row, second column. Second row, second column. First element times first element, second element times second element. First element times first element, second element times second element. 1.5 times 0 is 0, 0.5 times 2 is 1. So we get 0 plus 1. The 0 plus 1 plus right here is 1. So therefore shown, see? Therefore shown. Therefore shown. So you would have to know that the I matrix is actually this. So when you work it out, you get what it is. I would write this on my exam paper as well. And basically, that is it. All right. Next part. Determine A squared. Now, A squared don't mean that they're going to square the values of A. It means that you multiply A times A. What is A again? A is the matrix. Minus 1, 0. Minus 1, 0, 3, 2. Minus 1, 0, 3, 2. Yeah. 3, 2. Minus 1, 0, 3, 2. So squared means that you got to multiply it out. A times A, right? So A squared means A times A. Let's write that. A squared means A times A. Let's shift this over a bit. A squared means A times A. All right, I want to work it out right here. All right, so then A times A. So you line them up beside each other. So it means that A times A becomes, which is the A squared, it becomes minus 1, 0, 3, 2, minus 1, 0, 3, 2. You have to work the process again one more time. All right, let's zoom upon it. So remember, using the rows of the first matrix and the column of the second matrix, you're going to get 4 values again. First element here is in the first row, first column. So to get it, first row times this first column. First element times first element, second element times second element. First element times first element, second element times second element. Minus 1 times minus 1 is a positive 1. 0 times 3 is 0. Then this value out here is in the first row, second column. First row, second column. First element times first element, second element times second element. First element times first element, second element times second element. Minus 1 times 0 is 0. 0 times 2 is 0. So this is 0 plus 0. Then this value down here now is in the second row, first column. So multiply this second row, this first column to get it. First element times first element, second element times second element. First element times first element, second element times second element. 3 times minus 1 and 2 times 6. 3 times minus 1 is negative 3, and 2 times 3 is 6. The last value out here is in the second row, second column. So to get it using this second row with that second column, first element times first element, second element times second element. First element times first element, second element times second element. 3 times 0 and 2 times 2. The 3 times 0 is 0 and 2 times 2 is 4. So the final answer for A squared, let's put it here. This becomes a 1. This becomes a 0. This becomes a 3 because 6 minus 3 is 3. And this becomes a 4. That's the answer right there. And this down here says, explain why the matrix product AB is not possible. It's conformability and not conformable. Let's write it out. AB. Now remember, A is a 2 by 2. This is a 2 by 2. And the B was a 3 by 2. Let's look back at it. The B up here is a 3 rows. See there? 3 rows, 2 columns. So that's a 3 by 2. So the B is a 3 by 2. A 3 by 2. The B is a 3 by 2. I'm writing this to explain. This is a 3 by 2. And so the number of columns in the first matrix is not equal to the number of rows in the second matrix. They are not equal. That's why it's not possible. We have to write it out, right? So maybe if you write this one exam paper, I give it the marks, you know. But I would say number of columns in A not equal to number of rows in B. Number of columns in the first matrix A is not equal to the number of rows in second matrix, which is B. That's why it is not possible. They are not conformable for multiplication of matrices. That is the reason. All right. It says without calculation, state the order of the matrix BA, the matrix product BA. So BA is B coming in front now, would be a 3 by 2, that is the B matrix, times a 2 by 2. So this is the A times the B. They are conformable now. You put them in this order. These two are now equal. The resulting matrix will have the order taken from this and that. This gives me the resulting order. Resulting order. 3 by 2. So resulting order is at 3 rows by 2 columns. But the number of rows in the first matrix is 2. So the resulting is 3, sorry, so the resulting matrix also has 3 rows. The number of columns in the second matrix is 2. So the resulting matrix also has 2 columns. So this is the answer right here. Question done. End of this test. And that is that. Is that. Yeah. That was a good one. That was a good one. All right, I'll stay. 55. 55 is the answer. 55 is the question. Don't see a lot of persons online. I know what's happening here. All right, guys, let me hear some scores now. 55, 55, one more. Oh, no. Can't leave it now. They leave it 10 more to that. You could have got the next direction, of course. You get the same answer? You have to go the next direction and you get you're going to minus B. I don't have to go in the opposite direction. You just draw a diagram too? Oh, I'm saying you could go the opposite way, but if you go in this way, it would have been minus half of the A plus B. You understand? Let me show you. Since you asked me, let me show you. All right. So Mr. Paul is asking for this last question here for the MY. Let me shift it over and show you. So Neville is asking if you could have gone the opposite direction. Pay attention, quiet a little bit now, let's go through this fast. So he's asking if you could have gone the opposite way to go from M to Y. And the answer is yes. It don't matter the direction that you go. It's just that I like to go in the direction that we already know. It's because I already know X to Z, I prefer to travel along that direction. But to go the opposite way, you have to introduce a negative. But you can go, but you have to introduce a negative the right way. So I could have come back here first. This, hey, partner man. I could have come back here first and then go up that way, right? To go from M to Z. That's why they're asking, right? So I'm worked out yes or no. So you could have done it that way, yes. And it should have been to go from M to Y is the same as going from M to X and then going from X to Y. Just at the MX now, is the negative direction of this. It's half of this, but it's the opposite. So this would be minus half of the xy. That's what this would be. Because xy is going this way, but mx is going this way. And it's only going half the way, but negative. You understand? Good. So that's why you have to be careful. And you're going to add back this xy now. But the xy is just going to be a now, right? You must add back xy for now. Let's put in the values now. So first now is half of this, but opposite direction. So it will be minus half of that and minus half of that. So it will be minus half A and minus half B. You understand? And then now you're adding this A. And this is A. And you're adding this A now. And XY is A. You're going to work out to the same thing. Look, equals A minus half A give what? Half A. So a whole A minus half A give you a whole half A, right? You're getting half of A. Then this is the only B term there, minus half B. Minus half B. Same answer as this. She come already? I want you to send me and tell me what you got. I need to know what you got. Huh? 46? All right. So, do what question to make it wrong. All right. So, that is it. So you get the same answer. You can't go the opposite direction. No, you can't go any direction. It's all on the vector direction, but when you go in the opposite direction to a vector, remember to introduce a negative. All right. So much you get now. 72. All right. That's not bad for now, but you have to try. Even though we're at 55 and get 72, you still want to improve on the 72 next week. Eliminate the mistakes. Work over the question and make it wrong. All right. Cool. How much you get? So when you do the paper? So when you do it? When you do it? And you do it, reach back. Oh, all right. So when you do the next paper for tomorrow class, just class online tomorrow. So make sure you do that paper there. Try to do it today. May go. All right, that's very good. Oh, nice. Online, everybody online want to tell what they get, what they got. So far, so good. I hear some good scores here so far. $120 to $125. Oh, yeah, shot. Good fist. All right, my friend. Clean up. Mr. Birham, you do the paper? You do it at home yesterday? Ah, good. Come now, now go home. Come no man, no pass me. Can't no make ask how much I get. Let me hear the scores. Remember another mock exam, we have another paper to go through tomorrow. Right? Remember we have another paper going through tomorrow. Next paper. So if you have not done that paper as yet, you need to go and do it this evening. All right? The other people are going through tomorrow, you need to go and do it this evening. Once again. Huh? That's good. Just try and improve on it next week. You know, you pass the target, try and improve on it next week still. They're making progress. So you want to reach 95 as early as possible. 95 our target, but you want to reach there. 95 and above, you want to reach as early as possible before actually we have that target. 72 is good. Once again. Nice. Lovely. We're on course. Huh? Beautiful. So, Abraham, don't step through that door unless you tell me again. Huh? All right, good. What's it, Mr. Jackson? Huh? 68. You pass the target. I said the next week target will be 70. Yeah. So you know, say all the mistakes that we make this week, work on them. Come here, mom. Where you going? Oh. What's it again? Why? Why do I finish them? What's it again? Huh? Okay. We can't engage yourself properly and let's finish the thing, you know. So why do I finish it yesterday? You must have to finish it in the time of the exam, you know. There's no way you go and finish it. What you do in the time of the exam. Where you go, boss? If you're doing at the time of the exam, you have to talk about it. Yeah, but have to finish the thing at the time of the exam. Now what you do, and then where you go. When you come out to the exam room in an exam day, you know, you can't go back and do it for the paper, you know. So I need to know what you get in the 2 hour 40 minutes. That's what I need to know. Now when you go and finish up, it's where you're doing the time. So you have something, so you basically right around the target. Next week the target are moved to 70, you know. 70 at the target for next week. They know some of the mushroom, you know. You don't go over the question may get wrong and make sure you learn from the mistakes then. Anything you don't understand, you have to call me if you can't figure it out. You have to improve. And if you can move in the target. What you get? Huh? So you're just about above the target. So you have to make a big jump next week. You know what to do. Alright. What you get, boss? So you're still below the target. How you stay? Oh, hold on, I'm gonna stop recording. Alright, guys, online, nobody telling me anything. Mr. Morrison, talk to me. Shaquille never there yesterday. Zachary, bravo. I'm gonna sleep.
Sir, 63%.
How much?
63%, sir.
63. Alright. So you know you have to step up next week. Next week we move into 70. We're gonna get a little practice this week again now. 2 more papers to help you improve that 63 there. So you can come closer to the 70 we're aiming for next week or above. Alright. So you surpass the target, which is good, but we want most of next week we're moving the needle next week. Alright. What about you, Car? And brother, talk fast. We're gonna end the session now.
Pardon me, sir?
I'm asking you what I got.
Yes, sir. You hear me?
Huh?
Sir.
What you say? Yeah, man, talk now.
Yeah, sir. Yes, about 60, sir.
Alright. How about you, Zachary? Alright, nothing from Zachary. Nothing about our mic. Anyway, you hear the same instruction, Mr. Romela a while ago. Same goes for you. Alright? Moving the target to 70 next week. I have to move with the target by eliminating mistakes that you make on this paper. You get me? So during this week, we're gonna do 2 more papers that aim to try to get close to the 70 target for next week. So next week you can reach that 70 target relatively comfortably. Alright, so let's do 2 more papers. So remember, we're gonna check on the one for tomorrow. So if you did not do the one that we're gonna go through tomorrow, you need to do it so you can get a better grade tomorrow. Alright, guys, I'm gonna end the session now. So bye.